Alright, so I was thinking about doing graphs because it seems to be the most complicated data structure out of the ones that I've seen so far. So I was thinking about starting with the most difficult one, but I found this site from this guy here, and I thought it was pretty cool and brilliant that he did this. And it is free, so it looks like all of these are LeetCode challenges. So I think I'm gonna go through all of this. It's just the perfect thing. So shout out to this guy, really cool stuff he did here. So I'm gonna go over this list and I'm gonna put a limit for 30 minutes trying to solve these challenges. And then if I can't solve it, I'm gonna look at the video, obviously. And I don't think I'm gonna submit the solution if I can't solve it. I'm just gonna look at the video and I'm gonna mark the problem for trying to solve it later. I'm gonna try to do as many as I can. And then when I get tired of solving these problems, I'm probably gonna watch a bunch of videos on data structures and algorithms. Or I might end the stream as well. So let's start. 30 minutes here. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. I think I can use count. There are obviously several different ways that I can do this. It's an easy one, but I wanna see counts because I like getting familiar with things that I know but I don't use. Make an integer that returns evenly spaced values starting with number start. Often used as an argument. Or maybe it's not the intertools that I'm thinking about. It's just count. Often used as an argument to map to generate consecutive data points. Just sequence numbers roughly equivalent to. Let me see, count, Python. Yeah. Fruits.count and then the thing. So I can just use this for I in range length nums. If count I greater than 1, return true, false, return false. Oh, actually I can't return false. I have to return outside here because it needs to go through all the numbers. Let's see if this works. Oh, it has to be on the list itself, so I don't need to loop. Was the nums.count. I should also put this here. Oops. I forgot that is different in Python. I wish they put more test cases on each one. I feel like one is not enough to have a rough idea if it's good or not. But maybe they do it like this because they want you to buy the premium, which is fair enough. They put a lot of work into this, so I completely understand that. So wait, so why is this not returning? What? I don't get it. I think maybe another way you can do this is with strings. You can join the list into a string and then do substring or different methods like that. Oh, it's because it's nums I here. That's why. I'm testing for the index and not the number. But if this works, that's the easiest solution I can come up with off the top of my head. What? The list and the element. No, actually, it's better to print all of them. Oh, maybe they don't want me to loop over the list. Yeah, but how I'm gonna test for each element of the list? It doesn't make sense. So it's not as easy as it seems. Or maybe it's because I'm using counts and then it's counting more than the count takes more time. Hmm. I can do the two pointer stuff as well. One from the left, just like the three-sum solution. One from the left, one from the right, and then the index, and then I check if they're equal, but I don't think it's necessary here. It's probably an easier way to do it. Maybe we should just search for it. Yeah, count. Oh, sat. I can use the sat. I completely forgot about the sat. Nums. And if ras, then return true. Yeah, I think that's what they want. I always forgot. So set's probably faster. So how can I check if the set is empty? Length. I'm not sure if I can use length on sets. It's bigger than 1. Bigger or equal. Oh, actually, let me think. Oh, so if length sets is equal to length nums, then I return true. I think that's what they want. If any value appears at least twice in the array, every element is distinct. Oh, so it's the other way. If any value appears at least twice, so it means yeah, it's probably. I don't remember if I can use length on sat, but I think I can. Yeah, there we go. It's probably not the best, so let's look at the solution. I completely forgot about sats.
% on Educative.io today. Hey everyone, welcome back and let's write some more LeetCode today. So today let's solve contains duplicate. This is another problem from the line 75 list of questions we've been working on. So I like this problem because it's a good problem for beginners, but there's also multiple solutions to it that I'd like to go over in this video. So we're given an array of numbers. We want to return true if there's any value in that list of numbers that appears at least twice, but maybe it could appear 3 times or 4 times, right? Just at least twice. And we want to return false if there aren't any values that appear at least twice. Basically what that means is that every value in the array is distinct. So let's take a look at an example. We have 1, 2, 3, and then we have 1 again. So of course this has duplicates, right? So we return true, and the easiest way we would be able to detect that is by brute forcing this. So given these numbers, the first thing we do is look at the first number. It's 1. How do we know if this is a duplicate or not? Well, we'd have to compare it to every single number in the rest of the array. So that would be a big O of n time operation just to check if the first number is a duplicate or not. And then we'd have to do that for every number. Then we have to check, is the second number a duplicate? How do we know? We have to compare it to every other number. We do the same thing with the third one and the last one. And so since we're doing it for every number in the array, the overall time complexity is going to become n squared. And by the way, in this case, n is just the size of the input array. So the brute force solution is big O n squared time complexity. But the good thing is we don't need any extra memory, so the memory complexity is big O of 1. It's definitely not a bad solution, but the question is, can we do better than that? And yes, we definitely can. A second approach that will help us is sorting. What happens if we took this array and we sorted it? It would look a little bit different. It would look like this. Okay, but how does sorting help us? Well, let's think about it. If we sort the input, then any duplicates that do exist in the array, and clearly we see that 2 duplicates exist at the beginning of the array, they're going to be adjacent. So when we're trying to detect any duplicates in here, we only have to iterate through the array once. And as we do that, we're just going to be comparing 2 neighbors in the array, checking if they're duplicates. Next, we're going to shift our pointers to the next spot. Are these duplicates? Are these duplicates? Etc., until we finish the entire array. In this case, we see that these 2 adjacent values are duplicates, so we can return true. And what's the time complexity of this? Well, the one pass is just going to be big O of n, but we know that sorting does take extra memory, or not extra memory, it does take extra time complexity, and that time complexity is n log n. So that's the bottleneck in this solution. But again, we don't need extra space if you don't count the space that's used by the sorting algorithm. So in this case, we do have a slightly better solution than brute force. But actually, if we use a little bit extra memory, and it's really a trade-off, if we sacrifice space complexity, we can actually achieve better memory complexity, and let me show you how. So suppose we don't sort our input, we're given the default input, but we use extra memory. We use a hash set. But what exactly is a hash set going to do for us? It's going to allow us to insert elements into the hash set in big O of one time, but it's also going to allow us to check. We can ask our hash map, does a certain value exist? We want to know, does this 1 exist in the hash map? Well, if we start at the beginning of the array, so far, nothing is in our hash map, so a 1 does not exist in our hash map. That means this 1 is not a duplicate. You can see that this is an improvement over the brute force. Previously, to determine if this was a duplicate, we had to check every other value in the array. This time we don't. But after we have checked if this is a duplicate, we do have to add it to our hash set, because later on, if we encounter a 1, like over here, then we determine that this is a duplicate because we know that there's already a 1 in our hash set. So next we're going to check 2. 2 is not a duplicate, add it here. Is 3 a duplicate? Nope, add it here. 1, is this a duplicate? Yep, there's a 1 over here. So we return true. This does contain duplicates. And by the way, since each operation was just big O of 1, we had to do that for every value in the input array, and we only had to scan through the list of inputs once. The time complexity is going to be big O of n, but the space complexity, we did have to sacrifice a little bit. We have to create a hash set, and the memory that hash set will use could be up to the size of the input array, which is n, so we do end up using extra memory, but that's not too bad. This is about as efficient as we can get in terms of time complexity, so let's get into the code now. Okay, so now let's get into the code. So the first thing I'm going to do is create that hash set. In Python, you can do that just like this. It's just called a set, and then the simple thing is just going through every value in the input array nums, and before we end up adding it to our hash set, because remember, we want...
So this is the thing I was gonna say before I watched the video. I wonder how the set implementation is on Python, but yeah, I didn't know that. It's really useful to know. So a set is just turning a list into a dictionary, pretty much, which is interesting.
Want to add every one of these values to our hash set just like this. But before we even do that, we want to know, is n a duplicate? Does this value already exist in our hash set? And if it does, we know that our array contains duplicates. So we don't even have to continue through the rest of the array. We can immediately return true because we found a duplicate. But if it doesn't contain a duplicate, we're going to add that
What's up?
value, then iterate through the rest of the array of nums, and then the loop will exit, and then we can return false to indicate that we did not find any duplicates in the array. Now let's run the code to make sure that it works. And on the left, you can see that yes, it does work, and it is about as efficient as we can get. So I really hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot. Consider checking out my Patreon.
So
We can further
this
support
is
the
the
channel,
best
and hopefully
solution
I'll see you very soon. Thanks for watching.
And I guess these metrics here are not that reliable because it's just comparing your code with other solutions. So if the solution is easy, everyone can find it. So let's go to the next one. Let's set a timer. Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Damn, this sounds really hard, but it's supposed to be an easy one. Huh. Maybe all I have to do is see if one of the strings contain, if the letters in one of the strings exist on the other one. Yeah, I think that's pretty much the solution, probably. Because if they all have the same letters, it means that it's true. And it's probably why it's an easy one. Follow up, what if the input contain Unicode characters? How would you adapt your solution to such a case? Another path I think is regex, based on this follow-up. Yeah, but then it brings more questions, because how am I going to know if it's important? For example, let's say that there is a hyphen or something like that. I guess both of the strings are going to be words, so it doesn't matter, but... So let me try to do the easiest solution I can think of. It's probably not the best, I'm assuming, but... For I in range length if that's not fine. Or actually, it's better to do for I in t. Yeah. Turn true if t is an anagram, and false if it's not. And then I return true here. Let's see if this passes. Okay, passes this test. Oh, they both have true. Thanks for the follow. I'm assuming it's Sojking Sama. It's very small on the screen that I have, and I don't like to look at the Twitch screen, so yeah, but I'm assuming it's you because you talked in the chat. So I have to handle the case. So I can just do this here. Length of S is different than length of the T. Return false. But maybe that's not the case, actually. There's another case that I didn't think about. Because not only it has to exist, but it has to have the same count. Yeah, that's the problem. I have to count how many letters exist on each string and make sure that it's the same quantity. I'm just thinking about how I can do that in Python. I don't remember really well. I think I can use substring or something like that. But I wonder what's the best method. I can also maybe use count, but count is for lists, I think. And I'm not sure if that's probably bad actually as well. That count I is different than as the counts. Maybe R here. The issue with this solution is that I'm iterating on both strings every time I'm making this check, so it's not good. Move the letter when you check it, so you kind of track the number of occurrences. Yeah, I see what you're saying. But I think it ends up in the same problem. Because it might make more complicated as well, because then I have, thanks for the follow. I don't know what it is, but yeah. I think it might make more complicated because then I have to think about, I don't remember if it changes, if you remove a letter, it's going to change the length of T, which is going to change the I while we loop. So another thing in the same line would be to create a variable outside and then use this variable to count, but then it's the same thing because each time I'm counting a different letter, I have to... There's probably a method. I think I'm gonna search for the method. I think you're gonna continue there. Yeah. The first one that comes to my mind is this substring, but no, it was a different thing. No. Yeah, I know for sure that the way that I did there is not the best. It just doesn't make any sense to be the best. Oh, I know it, maybe. I was gonna say I can join the two strings and then yeah, but it doesn't make sense. Or I can use a dictionary as well. I think using a dictionary is probably better. But isn't that the same thing? Removing things when you're looping is always tricky. Yeah. I'm thinking about creating a dictionary, then looping over the T and making it the letters of the T equals to the keys, and then checking, looping over S and checking if but then it still doesn't. Oh, maybe if I increase the value as well, it could work, but it's probably the same speed and same ON, I think. Because I'm doing two loops and here I'm probably... Yeah, the thing is I don't know how long it takes to the count to work. I assume under the hood that the count is looping over the string each time, so with the dictionary it's probably faster. And let me try. I think I'm just gonna comment this out so I don't forget. I think this is gonna create... So if the letter is not on the dictionary, it's gonna initialize it with 0. Maybe I should do it with 1, actually. And then ours is gonna increase. And then I can use this dictionary when I'm looping through the... So if letter not in route, return false. But then, how do I check the value? I would have to use count here as well, so it doesn't change anything. I mean, there's several different ways probably to solve this. I think I can use combinations as well, probably. Oh, I think I found a different way to do this. That might be better. Let me erase this. So I maybe I can just sum them. Best way to concatenate different strings in Python. Let me just do what I'm thinking. It's gonna be res1 equals s plus t. And res2 equals res1.split, and then set if length res2 equal bigger than 1, return false. Yeah. Let's see if this works. Hmm. It shouldn't be bigger than 1 in this case. Because I'm concatenating them. Because essentially, if it's an anagram, they all have the same letters. So if you concatenate them, then you turn into a list and return into a set, it should have length 0. Otherwise, it would be... there would be some unique letters. I'm just print... rest, sure. I'm not sure if it matters as well, how many submissions I have here. Maybe I should be copying these inputs and putting on the test case here. But I'm just too lazy to do that. So it might be, let me just do this and see what happens. Yeah, it's because the thing is I can't split based on... I had the same problem as well in other instances. Where I can split based on the letter. That's the issue. And then I have to do... yeah, I can just do this I for I in res1. Now it should work, I think. Maybe I should put this set here. It's easier. Then raise from here. How is this possible? It's definitely on this that the mistake is, but let's see. Can I do set directly on a string? Let's see. Yeah, but then I can. So this is unnecessary. Oh yes, it's because I'm reducing to the unique one, but I'm not removing. That's the thing. I'm only removing the ones that repeat. Hmm. Maybe I can sort as well. I can do sort first, then set, then check by comparison. Yeah, that's a good idea. Or actually, I can just sort in zip. It's probably better. I'm gonna have to look it up how it works. It's probably not worth to spend a bunch of time on this one as well, because it's an easy one. There's probably um, not enough values to unpack there, the problem. I'm always confused as well by these values here. I'm never really sure what to do. Let me see. Oh, because it's gonna be the tuple. Okay. So I think each value is a tuple. So, and the tuple is gonna be one item of S and one item of T. So B is gonna be a tuple with one item of S, one item of T, I think. But I'm not sure. So this is the problem here. I think it's just sorted string. Oh, there we go. I think I got it right with the removing thing. Share it with me. And how good is it compared to the other submissions? I think this solution is worse than the other one, if I remember correctly, but I'm not really sure. And there's probably a better one because this is not that good. Oh, that's fine. Yeah, if you want to share it, then share it. If not, that's fine too. I think I'm just gonna look at the video now.
Head over to educative.io/LeetCode to save 10% on your subscription. More on that in a moment. Hey everyone, welcome back and let's write some more neat.
My goal is to spend less time on these ones because, and as far as seeing here is just easy and medium. There's very few hard ones. I think this I saw the solution on a video, but I know it's really hard, but I don't remember how to solve it. But I remember seeing a course about this one. So my goal is pretty much to, it's not even to solve the questions, but more to understand how it works. So I think on the easy ones, once I get the gist of it or the logic behind it and the line of thinking, I don't even care really if I get the answer or not. It's more about understanding the principles behind it. So I think I'm gonna stop more on the mediums and hard ones, because those are the ones that I have difficult time understanding the thought process behind them, or of how people get to the solutions. And so far, the hardest thing is understanding when to use something. So hopefully doing things like this is gonna help me understand when to use each thing to solve a problem. If length s different than length b, return false for I. Pose b dot find I, print -1, return false. I think the way that you pasted here is very similar to the other way that I was doing, but it is slightly better because you're not counting. But I'm not sure if it's the best way as well. So the first condition is to check if this one, then the other loop here. Yeah, so we're pretty much using as, and then you're using the string, substring here. Yeah. So let's look at the solution from this guy.
LeetCode today. So today let's solve the problem valid anagram, and we're actually going to be solving this a few different ways, so maybe you will learn something today. So we're given two strings s and t, and we want to return true if t is an anagram of s, or basically if both of the strings are anagrams of each other, and false if they're not anagrams. So main thing that they don't mention in this problem is what exactly is an anagram, and basically it means that, to call t an anagram of s is basically saying that using the characters of s, all of the characters, right, every single character, we can create the string t. So basically they're made up of the exact same list of characters. So the string s, you can see that it has 3 a characters, 1 n character, 1 g character, 1 r character, and 1 m character. So it's made up of, in total, 7 characters. So that must mean that if t is an anagram of s, t has to have exactly 7 characters as well, which clearly it does have 7 characters, but are they the exact same characters as I wrote up above? Well, let's check. Okay, does it have 3 a characters? 1, 2, 3. Yep, it has 3 a characters. Does it have a single n character? Yep, it has exactly 1 n character. Does it have a g character? Yes, exactly 1 g character. Does it have an r? Exactly 1 r. It has exactly 1 m as well. So it has the exact same characters and the same quantity of each character. That's also important, right? Because 3 a's have to exist in t as well. So in this case, they're anagrams. We can return true. That's great. Second example, rat and car. Both of them have an r. Both of them have an a character, but one of them has a t, while the other has a c character. They're both the same length. They're both length 3, but they have one differing character, so they're not anagrams. We return false in this case. So the first solution I want to talk about is probably the most obvious one, and probably by just listening to me talk about anagrams, you might be able to come up with this by yourself. We just want to count the occurrences of each character in both strings, right? What's the easiest way to do that? Well, you could use an array or a hash map. That's what I'm going to use. I like hash maps. Basically, what the hash map is going to look like. So basically, we're going to have 2 hash maps, one for each string, and the key value in the hash map is going to be the character. So for example, a in string s, right? Let's use a different color. So a in string s. So how many a's are there? There's 3 a's, right? The value is going to be the count. The key is just going to be the character. We're going to do that for every single character in the string. So
I think so far those are the patterns that I'm most familiar with. Every problem that I solved seems to involve these ones, which is basically one a hash map is converting a list into a hash map or a string. And the other one is the 2 pointers, where you have one starting in the beginning, one starting at the end, and then you do something along those lines. I think I'm pretty familiar with this already.
N has 1, G has 1, R has 1, and M also has 1. And we know that T is the exact same, right? It has 3 A's, 1 N, etc., etc. Right? I could continue this. So in the end, you can see that they're the exact same hash map, right? Once we built these hash maps, we can then go through the keys and then compare that the counts for each character are the exact same, which in this case, yes, it is. So then after that comparison, then we know that they're anagrams, then we can return true. And how exactly I'm going to do that is I'm just going to actually iterate through the keys of one of these. So in this case, for example, I'm just going to iterate through all the keys in string S. So A, N, G, and then make sure the counts, right? We want to make sure that the count of each of the characters is the exact same. And if we make sure that both strings have the exact same length before we actually do the hash map stuff, then we actually only have to iterate through one of the hash maps and comparing it to the other hash map, right? Because if we make sure that T has exactly 3 A's, T has exactly 1 N, T has exactly 1 G, etc., etc. If we make sure that all of that is true and that's inside of T, then we pretty much know T is exactly the same as S because they have to be if they are the same length. So that's the solution. Time complexity of this is big O of N, or rather, let's say big O of S plus T, because we're going to have to iterate through both of the strings. So that's the time complexity. The memory complexity is the same, S plus T, because clearly we are building hash maps that are going to be of size, potentially up to the size of S and the size of T. So the downside of the solution is we are going to need some extra memory, and the second solution that I show you is actually going to solve that memory problem. So stay tuned in the video if you want to see that. But for now, let's jump into the coding solution of this hash map solution that I'm talking about. Before we continue, let me tell you a little bit about Educative.io. Educative.io is a platform with hundreds of varied courses, and these courses are comprehensive. This Python coding interview course about it because we got you covered with similar coding. Like I mentioned, a main thing we're just going to be doing is counting the characters in both of the strings. So we're going to create hash maps for that. This is how you can do that in Python. But remember, before we even do that, we want to make sure that the length of both strings is exactly the same, because if they're not the same length, then of course it's impossible for them to be palindromes. So we can immediately return false if they are not the same length. Otherwise, we can actually run the algorithm. So let's just go through the strings at the same time. So we can iterate basically through the length of the string S because we know they're both the same length. So we can just use the index I for both of the strings. Count S is basically going to count the occurrence of each character in string S, of course. So each time we see a character, so a character is basically going to be S at index I. That's the key of the hash map. Every time we see a character, we want to increment the count of that character by 1. So can we just say 1 plus this? Can we just say 1 plus this? Well, in Python, no, because what if that character doesn't even exist in the hash map yet? Then this is going to throw a key error, right? Key does not exist. So to get around that in Python, at least, there's a nice little function with hash maps that you can use that's called get. So get this, this key, and it'll basically do exactly what's being done over here on the left side. But the second parameter to this function is basically a default value. So 0 is the default value in this case. That means that if this key does not exist in the hash map, then the default value that this function is going to return is 0, which is of course what we would want it to return, right? So with this line, we're just counting the occurrences of each character in string S. We can do the exact same thing with string T just by copy pasting this and then changing everything to T. So making sure we use the T hash map and making sure we iterate through the string T, right? T at index I. So that's pretty much it for building the hash maps. Next, we want to iterate through the hash maps and make sure the counts are the same. So let's say for C, for the character in count S. So we just want to make sure the counts of both hash maps are the same. So count at character I is equal to count T at character 0. So exactly what I just showed you, equal. Basically, by doing the equal sign, I'm just doing, I guess, the overall time complexity and space complexity. Good question. And the solution is actually simpler than you might think. Just kind of thinking about how anagrams work. If you took all these characters and put them in a hash map where we can count the occurrences, then it's pretty easy to check if they're equal. But isn't there another way? What if we made sure that the characters show up in the exact same order every single time. What do we mean by order? Well, one possible way would be sorted order, right? Because if they really are the exact same characters, then if we put them in sorted order, then they should actually become the exact same string. Then we can literally just do an equals operation on both of the sorted strings and guarantee that they're going to be equal. But the downside is, what's the time complexity of doing sort? Well, in some cases, with bad sorting algorithms like bubble sort or something, it might be n squared, right? Good sorting algorithms can do it in n log n time, right? Worst case, big O of n log n time. But the space complexity is kind of iffy. Usually, sorting algorithms, at least good ones, actually do use extra memory. They use O of n extra memory, but sometimes they don't. Sometimes they can be really optimized and actually run on constant extra memory. It will depend on which built-in library function you're using, but usually for some reason interviewers just assume that sorting doesn't take extra space. So it's definitely something to discuss with your interviewer. Yeah, so basically if you just sort it, it solves the problem for you, right? Because if we took Anagram and we sorted it, we get AAA, G, M, N, R, right? It would be the same order. And then if we take this string T, sort it, it's the exact same characters. So when we sort it, it should be the exact same string, and it is. So now let's get into the code of this solution. Okay, so now you can see that these were the two solutions we originally came up with. Now let's do the third and final solution. We can just run the sort function on S and the sort function, the built-in sort functions at least in Python on T as well. And if they're exactly equal, it'll return true. If they're not equal, it will return false. Let's run it to make sure that it works. And on the left, you can see, yes, it does. It's relatively efficient. But technically, it's not as efficient as the two previous solutions that we came up with below. Who knows, maybe your interviewer will actually want you to write out your own sorting function for this. But I really hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot. Consider checking out my Patreon where you can further support the channel, and hopefully I'll see you pretty soon.
I didn't need to do this stuff here. The zip thing. Okay, nice. So next one. Choose some. Yeah, so now let's see if I remember how to do this. I did the 3-sum and the 4-sum before. So this one should be easy for me, but I'm not sure if I'm gonna remember how to do it. Given an array of integers num and an integer target, return indices of the two numbers such that they add up to target. We assume that each input would have exactly one solution, and you may not use the same element twice. So the way that you do this, I think, is for I in range like nums. Then you have 2 pointers, left, right, I plus 1, and then if nums minus 1. While left is, well, I also have to sort here. Nums not sort. If left, if, oh yeah, there's also the sum. Have fun. See you next time. Yeah, sure. Thank you. So nums left plus nums right. I don't even need the left one now that I think about it. But I'm gonna do it like this because I think it's easier. So if sum is lower than 0, then left plus equals 1. If sum greater than 0, right minus equals 1. Else left plus equals 1. While left, right, and nums left plus 1. Oh, I need an array as well here. So new, or at least I should say, new dot append. So from what I remember, that's how you do it. But I might be missing something here. Well, the other thing that I didn't do is check for the condition. But I don't think in this case I need to, because it's just 2 pointers. So I think here I would have to check if nums left is equal to nums left minus 1. And then if it is, you continue. Or something like this. So it's if left is greater than 0. And so you don't run out of the index. Yeah, I think that's how you solve it. Let's see if I missed something. I'm not using target here. That should be target. Now it should be the correct way, I think. Just this part that is always tricky, that I didn't fully understand yet. Oh, -1. Or maybe, I think it's +1 actually. From what I remember. So I'm probably doing something wrong here. Maybe I should make nums equals nums.sort. I don't think that's the case actually. Oh, I'm not returning. What am I doing? Return new. And it still doesn't work. So let's see. Primary range, length nums. Maybe it's if left lower than 0. Or if f. Yeah, but then that's the problem. And let me remove this and see if this is the problem first. It doesn't look like it is. Turn indices of the shoe numbers such that they add up. So here I should add left and right as well, instead of adding the numbers. So then add up to the target. We may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's see, what am I doing wrong here? If S, maybe it's the order that I'm doing wrong here. If S is lower than target. No, but in my mind this seems like, because if the sum here is lower than the target, it means that I need to increase the number. in order to get the target. So I think this part is correct. But maybe this should be here on top of this. But I remember being inside of the while loop. But maybe it should be here. Let's see. It's still empty list. I don't get it. Let me change the signs and see if it changes anything. It's obviously something that I'm missing, but what if I do this? And if I was gonna solve this problem, this specific problem, without trying to do this algorithm, I'll probably do it differently. And I think that I can think about easier ways to do this than trying to implement this. But it's obviously better to try to implement it because I know that is the best solution for when the problem scales, at least. So I should push myself to think about it in this way. And I'm pretty sure these signs were correct because it doesn't make sense otherwise. If the sum is greater than the target, it means you need to decrease the result of the sum. The only way you're gonna do that is by changing the right. It has to be on the last part here that I'm messing this up, I think. Maybe the left plus equals 1 comes after, but it shouldn't be an empty list anyway. So this has to mean that I'm making a mistake before that, but I just don't see how that is happening. Maybe if I print left and right here, just see if I'm getting the right variables. Yeah, so this should be -1. So 0, 3. Then 17. Then 1, 3, 22. So I'm increasing. It should be decreasing. So maybe it is the values that are incorrect here. No, same thing. Hmm. I guess it's because it's just going through the outer loop. So the target should be 9 here. So 9. 17 is greater than 9. Left plus equals 1. And it should be this way. So let me print here to see what's happening here. Oh, so it is decreasing. Oh, I need to make the sum inside of this loop. That's the problem. Because I'm not updating the sum, so it's not catching. Now, hopefully it's gonna work. Okay. Oh, I need to put this in a list. Yeah, still getting the wrong answer. Oh, I need to append. Okay, so same thing pretty much. Hopefully this works on the... Yeah, I'm gonna have to spend a lot more time thinking about this two pointer stuff. Because I'm pretty sure if I'm going to do the 3 sum or 4 sum, I'm not gonna remember how to do that. Hmm. No, so the thing is, I'm not updating the left and right, but I should be. Let me think. Because here is printing 1, 2, and then 1, 2 again. But I'm pushing 0 and 2. Oh, so maybe the left plus equals 1 should come first. But then is it gonna screw up the other ones? Probably. I don't think it's gonna pass this one then. I don't know what's going on here. Maybe let me print here. It's obviously gonna give me so why does it give me 0? Sure. Oh, because I'm increasing the left. Oh, actually. So let's think. I start with 0 and 2, which is 3 plus 4, 7. Yeah, I'm getting started. Thanks for the follow. I assume it's you, Olala8. Yeah. I did the 3-sum and the 4-sum already, but I don't remember really well how to implement. I'm probably gonna have to look at them a bunch of times until I finally can do it off the top of my head. But I remember roughly the logic, but there's something that I'm missing here that I don't understand. So I have 3 and 4 here is gonna be 7. 7 is greater than 6, so it's gonna hit this one. And it's gonna decrease. Oh, so maybe I have the signs messed up here. Set? What do you mean? A single set? I need to return all the sums, all the indexes where the sum is gonna be equal to the target. My idea here is, well, I'm pretty much following what I think is the solution for the 3-sum and the 4-sum, if I remember correctly. But pretty much you have 2 pointers, and then you sum these 2 pointers to see if they're greater or lower than the value that you're looking for. And if they're lower, you increase the left pointer because the list is sorted. If they are higher, you decrease the right pointer. And you do this over and over again until you reach the target. If you reach the target, then you append to the list the indexes. And then you do this check to see if there are repeating numbers. If the left is equal to the left plus 1, because then it's going to be repeating. And then you increase while this is true, so we don't have the repeating stuff on the final list. And then after that, you do this over and over again for all the elements, and that's the solution, I think. Hash set of visited numbers with 3 sets. Oh, yeah, I have no idea how to solve it with maybe I can think about how to solve it with a set, but the solution that I've seen and then that they recommend is using this one, where you have 2 pointers and then you calculate And then the more number of sums you want. So if you want to sum 3 numbers or 4 numbers, it becomes a different problem, but it's basically the same idea. You just use more pointers until you get to the true sum, and then you put all the elements in. But for sum, I didn't understand really well, because they use recursion, and there's a method there that they use that is a little weird. I don't understand why they put it there, which is they put an item in the list of the results, then they call the function in a recursive fashion, and then after that they pop the element, and it doesn't make sense to me. But it's pretty much the solution by this guy that I watched. And so far I like these videos. They're really good. Yeah, this one.
Head over to educative.io/neat.
Go through the whole array, check if target. I don't understand that this element is in visit already. Yes, return both. No, push this element into set. So you're talking about the other solution. Oh, I see. I think I understand what you mean. But how do you check the sum? Did you loop through the list? Like you do a nested for loop, and yeah, sure.
LeetCode to save 10% on your values from the same index in a single quadruplet. So there's really 3 cases here, though, with our 2-pointer technique. Either are...
If you understand this and you can explain me, it would be really helpful. It's kind of confusing too. I don't expect you to know, of course, but it's Owen. Yeah, I'm not sure with the 2 pointers how fast it is, but I think it's pretty good. If it's not one of the best, it's probably... If it's not the best, it's probably one of the best. Does it matter how many submissions you have? Like, is it best practice to just copy the test cases and add them here? Or it doesn't matter if I submit a bunch of times? Because I'm too lazy to keep copying the test cases and putting them here. Just find it easier to submit a bunch. Yeah. Okay, so... Oh, this is the solution. Yeah, pretty clever. I kind of want to solve it the other way, though. Because obviously I don't really care about solving the problems. I care more about understanding the ideas behind it and the principles, and learning how to think about how to approach each problem, and how to... The most challenging part is figuring out which approach to choose to solve each specific problem. That's the thing that I found the hardest so far. So I'm trying to see if I can solve these problems thinking about that. So, because obviously in real life you're not gonna know if this is a graph problem or a binary tree or whatever. You just have the problem and then have to figure out. So same way. And I guess it's really hard to know what's the best approach, right? That's the issue. And usually I'm more used to choosing hash maps as well. It's just more intuitive to me, but I think it's interesting to explore these solutions as well. Do you understand this one? If you understand it and you wanna try to explain to me or something. Grind 75. What is this? 3 sets, positive, negatives, zeros. Yeah, grind 75 is a problem set. Oh, problem list. And what's the objective behind this list? How can I know? I know that I can do lists from LeetCode, but I didn't know you can follow specific custom lists. My plan is to follow this list here, because this guy, his channel seems to be just focused on this thing, and I found it really cool what he did here, and it's pretty easy to follow, and I can watch the videos after. I'm giving half an hour for each problem. If I can solve it, then I watch the video and I mark the problem for later. Oh. Oh, it's another site. There's also binary search as well. Seems to be really good. People on Twitch seem to use it a lot as well. Do you understand this approach though? With the 2 pointers? Can you figure out what I'm doing wrong here? There's letters at the left. No, so I think I'm just gonna. Yeah, if you want, if you don't want, it's fine. I can just watch the video, obviously. But if you want to look at and try to figure out, as letters at the left, if you want more problems, yeah. Oh, maybe I should actually put this on my favorites. I think it's gonna be hard to run out of problems on LeetCode, but who knows? Because I think I'm gonna get really crazy on this, to be honest. But I did the calculations, and even if I spend 10 hours a day for 30 minutes each problem, it's still gonna take me months to run through the whole problem list on LeetCode. So. Oh, okay. Except DSA, I assume, is data structure and algorithms. Yeah, I don't think so much about it in this way, because I think focusing on interviews is more focusing on the effect, not the cause. I like to think more about the cause first. So the cause of getting a job or making money is being good, and then the effect is getting money or getting a job. And focusing on the effect, you can't really control that. But if you focus on the cause, you can always improve. So I don't like to study that much to pass interviews, or with that mindset to pass an interview or to make money. It's more about becoming better and better until I attract that stuff to me. So I don't like this style that much. I prefer these problems here. This one feels like it can be useful. And I'm sure that there's a lot of value in the book as well, but I don't think it's for me. Yeah, sure. So do you want to try to figure out what I'm doing wrong, or should we watch the video? I think I'm gonna close this for now. I'm probably gonna look at this after I spend a bunch of time on LeetCode. Or doing these problems here. Oh, okay. No, that's fine. Completely fine. So I think I'm gonna watch the video and see why he does. He probably solves the same way. Because that's the way he did it on the other ones.
Let's solve LeetCode 1 2-sum, the most popular LeetCode question. So we're given an input array and some target, in this case 9, and we want to find the two values in this input array that sum to 9. So in this case, it's 2 and 7. Now we want to return the indices of these two values. So the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. Now the most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So we start at 2, we check every combination we can make that includes 2. So we scan through the remainder of the array 1, 5, 3, and check if any of those numbers added to 2 sums to our target 4. In this case, none of them do. So next we can repeat the process. Let's check every combination, including 1, that sums up to target 4. So we scan through every element.
Are you preparing for interviews or something like that? How long have you been studying on? Do you do LeetCode or this grind 75 or any other sites?
After it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that the overall worst case time complexity will be O of n squared. So can we do better? Now the thing to notice is that for each number, for example, 1, the
Yeah.
value we're looking for is the...
I think a lot of people do this just for fun. And honestly, it is kind of fun. I enjoy it. It's like lifting weights, pretty much. You become better after solving a bunch. And helps you understand more how it works. At first, I didn't like it because I didn't see the link between this and practical stuff. But now, the more that I study and that I think about it, I can see the connection there. But initially, it's hard to see it. Especially in the beginning when I was just starting out, because you have no idea that everything works based on these data structures, and you're kind of clueless. So, but now I get it.
Difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number. We just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check, does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map? And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. We can't use the same value twice, so we would have to compare the index of our current 2 with the index of the 2 that's in our hash map. There's actually an easier way to do this though, and it's a little clever, and let me show you how to do it that way. So doing it this clever way, initially we say our hash map is empty. So we get to the value 2 first of all, right? And we want to look for the difference 4 minus 2 in our hash map. Our hash map is empty, so we don't find 2. So then after we visited this element, then we can add it to our hash map. So now that I'm done visiting it, I'm going to move to the second element 1. And before I do that, I'm going to add this value 2 to our hash map, and the index of this value is going to be 0. Now I'm at 1. I'm looking for 4 minus 1, which is 3. I see 3 isn't in our hash map, but it actually is in our array. So what's the problem? Well, for now we're going to say we don't find a 3. So we add 1 to our hash map. The index of this 1 is 1. And now we move to the next element 5. We check, does 4 minus 5 exist in our hash map? That's -1, so no, it does not. Then we add this 5 to our hash map, and its index, which is 2. And we move to the last value in the array, 3. We check, does 4 minus 3 exist in our hash map? Now that's 1, so we see it does exist, right? Right over here. The value exists, and its index is 1. So now we found our two values that sum to the target. And we want to return their indices, which are going to be 1 and 3. So with this algorithm, we don't have to initialize our hash map. It can be initially empty, and then we can just iterate through this array in one pass. Now, the reason the algorithm can work in that way with just one pass is this. So let's say we had a giant array, right? We know for sure that there are two elements.
So I think pretty much the way that it is working is whenever you find the value and you subtract from the result, you put it on the hash map with the index. And then if that value exists on the hash map, then it means that the sum is the target. So you return the value, the key value, plus the whatever value you stopped at. But I don't fully understand the details.
Array that sum to our target, right? We don't know where they are. They're at some arbitrary location. When we visit the first one of those elements, our hash map is only going to be this portion of the array. It's only going to have the values that came before the first value. So we're going to notice that the second value that can sum to the target is not going to be in our hash map yet. But once we get to the second value, our hash map is going to be this portion. So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map, so we're guaranteed to find the solution. Now, since we only have to iterate through the array once, and we're adding each value to our hash map, which is a constant time operation, and we're checking if a value exists in our hash map, which is also a constant time operation, the time complexity is...
Insert it only if target this is not found, if in the visit hash table. Target minus this. Yeah, minus. And the reason why is because the sum has to be equal to the target. I think I get it. It takes some time to me, even though I get it, to come up with this stuff off the top of my head and to write it down on the programming language. I'm not sure if it's just me, but I assume it's probably everyone. Because even though I understand the logic, is a little bit confusing when you're going to implement. But I think I understand now.
Is going to be big O of n. We are using extra memory, right? The hash map isn't free, so the memory complexity is also going to be O of n because we could potentially add every value to the hash map. So now let's code the solution. So remember, we need a hash map, right? I'm going to call this previous map because it's basically every element that comes before the current element. Every previous element is going to be stored in this map. We're going to be mapping.
But it's weird to me that he didn't solve in the same way that he solved 3-sum or 4-sum.
The value to the index of that value. So now let's iterate through every value in this array. We need the index as well as the actual number. So let's do it like this in Python. Before we add this to our map, let's check if the difference, which is equal to target minus n. Now let's check if this difference is already in the hash map. If it is, then we can return the solution, which is going to be a pair of the indices. So I can get the first index like this.
Maybe I'm confusing. I think I'm confusing the problems, actually. Because now I remember that initially, I think on the 3-sum, without looking at the solution, I used the hash map as well. And I actually created a list with a set with the sum of the values. And then I was doing something with a hash map to compare the difference. Pretty much the distance between the target. Yeah, I think it was the 3-sum closest, actually. But it wasn't the exact value. You had to return the closest approximation of the target, or the target if it is equal. So maybe I'm confusing the problems.
Second index is just I. Now, if we don't find the solution, then we have to update our hash map. So for this value,
target minus this is the number we need to sum with this to get target. Yes. Target minus this equals needed. This plus needed equals target. Yeah. Guys, the only thing that I don't understand yet is in relationship to the indexes of the hash map. Because are you looping only once through the thing? Through the list? Let me see the code, the full code, then I think.
And then we're going to continue. Since we're guaranteed that a solution exists, we don't have to return anything out here, right? But I'll just put a return for no reason. Now let's see if it works. And it works perfectly. So
okay, so you're iterating to the nums, then, like you said, the difference is target minus n. And then if the, so it checks to see if the difference exists on the map, the hash, which is the result you're looking for. So if it exists, you return proofs minus, and then the element. Oh no, we return with the index. We need this hash set to get O1 for lookup instead of ON in brute force approach. What does this line 8 here does? Because in my understanding is returning a list with the value of, is creating a value in the priv map. Oh, actually, this is if it exists. Okay, never mind. So if the difference exists, it means that it is equal to the index. It is, the key is the value. I think I get it now. Or do I? It's a difference argument than previous. Alright. Just creating a value for each. It's creating a key for each value of the nums and making it equal to the index. Oh, so if the difference, it means that it's equal to the key. Yeah, I think I get it. It's just a little bit confusing, but I think I got it. Because you're only looking for one answer, I guess. You're looking for the value and the index of the value. No, we're looking for both indexes of the numbers. So this is the index of the first number, and then this is the index of the second number that completed the target. Yeah. Return index of already visited, needed element and current element. Key is num, value is index. Yeah. But doesn't this return only one sum? What happens if there are two sums that equal to the target? Then instead of returning, you would append to a new list, right? And then return a list at the outside of the loop, I assume. Yeah, but what if the problem was asking for more? I think it's the same logic, you just append to a list outside and then you return the list outside of the loop. But maybe no. Because it might change the dictionary actually. Depends if you can use same number twice. Yeah. It gets more complicated though. Oh no, I have to see if I can write this off the top of my head. Do they sort? No. So the difference is target minus value. If diff in priv, then return value and the index. And then here would be prav value is equal to the index and return. I think that's the way that they did it there. Let's see. Priv diff, not priv value. Because it is the same. So I'm getting the first element and then the index of the second element, which completes the sum. Let's see if it works. Spray that works. Yes, nice. I still don't understand though why the solution is like this for this one and slightly different. But I'm probably gonna revisit the other ones at some point. Definitely gonna revisit. Maybe there is the tree sum and the other problem are on this list as well, probably. And now it starts to get hard. I think I'll be right back. I'll grab something to drink. Because storing all possible pairs in the map is not a good idea, because I would be backtracking as a prep step. I've heard about backtracking a lot, but I have no idea what it is. But I know it's useful for solving a bunch of problems. It's something I have to study as well. Hopefully there will be problems, probably there are problems in this list that involve backtracking. But I think I was talking about the other solution with the 2 pointers, not the one that stores the values. But I don't understand them. The 3 sum, I think I kind of get it, but for the 4 sum and the other ones, I have no... it's not like I don't have any idea, but I wouldn't be able to implement it myself unless I'm going strictly from memory. Then I might be able to, but I don't understand it at all. I'll definitely have to revisit at some point. Something like return all possible combinations of arguments. Oh, I skipped. Because that would be backtracking is simply exploring all possible solutions. Something like return all possible combinations of arguments. So is it like iter2's product or combinations? Because I think that's what the product gets, all the combinations of 2 different lists, I think, and combinations gets the combinations of a list, I think, or of 2 different lists, all combinations. So product is for the Cartesian product, as far as I remember, and combinations is for just combinations. I'm not really sure exactly what the difference between them is exactly, but I know that's what they do. Given an array of strings, group the anagrams together, you can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Group the anagrams together. Oh, okay, so I have to see which ones are anagrams and which one are not. Combinations, permutations, subsets, top 3 basic backtracking problems. Okay. Yeah, so it doesn't seem like it's that hard, but maybe I'm wrong. A lot of the times when I feel something is very easy, is usually deceiving and it's a lot harder than it looks. So at least from the problems I encounter on Cold Wars. Yeah, that's also another thing that I have to study that I kind of know, but I don't really know at all. Just depth first search, I think. For traversing graphs, maybe is useful. Yeah, so this one is a lot harder than the other ones. But what comes to my mind first is loop through the list, then sort all the elements, and then make an if condition or something like that to store the ones that are equal in different lists. But it's a graph of sub-problems in that case where leaf is the solution. It can be solved the same way. Map sorted, unsorted. You're talking about this one? I don't think so, because this is not, but maybe I'm wrong. Backseating? I don't know what that is. I don't care about solving the problems. I care about learning. That's it. So it really doesn't matter to me if I get it or if I don't get it. It's more important to learn. Yeah, sure. I'm very, very new to this. I know programming, but when it comes to data structure and algorithms, I'm a complete noob. So sort each word by its letters. Yeah, so first looping through the strings and then sorting, right? Yeah, I just solved a problem for the anagrams stuff. Word by word basis. Yeah, but then I have to loop, right? To the... Like you're talking about this. Yeah, mapping works as well. Or I can just do sorted, but then I have to put the number anyway, so. Is there a better way to do it than do it like this? Or I can just do the thing? How do I Control C? I control then scroll like this. What language do you code in? Olala. Is this good? The size? So the first part I understand. I sort and then I check to see which ones are equal to the other ones. But then how do I divide them into different lists? Oh, I don't need to sort the strings. Create a hash for each sorted letter list. Oh, I think I understand. So let me think. Oh, I think I understand what you mean. So I created a version of each letter in the map, and then I compare that version with the other ones, and then I create different lists based on that. But how I'm going to know this? How many sizes? How many lists I should have? Oh, based on the keys actually. I can make the list equal to the value of the key on the map. Yeah, I got it. Do you think this is the best solution, or can we think about a better one? I always tend to think about using iter tools because it's something I'm not familiar with, and there's a lot of useful stuff there. So maybe you can use that. Yeah, I think I understand your logic there, Barry. Just map key as sorted string value is the list of unsorted. Just map key. I think we're both talking about the same thing, probably. It's just a misunderstanding. Hmm. Yeah, you're talking about the same thing, but with different words, I think. Are any of you familiar with the Python methods, iter tools, combinations and product? You think it's possible to use that here? Maybe to get better solution? Or maybe using cycle or something like that. Yeah, how can we do it in one line? The issue is, first, I think no matter what, you have to sort each string so you know which ones are equal. But maybe you can use that to split the original string into other strings. And then if you are able to capture the index somehow, you can use the indexes to add the elements of the original string. But create a function called sorted letters and then use reduce and group on that. Let's see if this works. So you're saying something like this. Like this? No, this doesn't make sense. Okay. Yeah. Let me think about how to translate this. Yeah, but the thing is, even here, it's kind of like you're doing a nested for loop, right? Because you're mapping each element in the list again. I'm trying to think about... obviously, what I'm doing is unnecessary. You can just solve the problem using your solution, but I just like to think about the best way possible that I can think of, even if I can't solve the problem. Just to force myself to do this, to use these methods that I'm not comfortable with using. Yeah, but isn't the map like a loop inside of the loop as well? Or your same map is just the hash and something that I'm not understanding? Might need an if condition to see if maps already exist. Like, are we talking about this? Maybe I'm thinking about filter instead of mapping. No, that doesn't make sense. Hmm. What do you think about using zip? You can use sorted it and it's gonna sort. Yeah, what I can do is also make strings equal list map lambda x sort x strings, and then this is gonna return the list with all letters sorted, and then I can do the operations on this list. Oh, I have an idea, I think. Oh, but maybe this makes sense. For zip, you'd have to create a second array, and you actually want the reverse hash, not the forward hash. I was thinking about using itertools product, and then, but then the only issue is I can't compare the values. So let me think. Because if I could have all the combinations, all the possible combinations within the values of the list, then I can sort all of them and see if they're equal. So I create a new list or append to a new list. But this way I also need the hash. That's the problem. I don't think I can get away with not using the hash. So probably the way that you're suggesting is probably the best at the end of the day. So this sorts all the elements in the string, then I have to create a value for each one, I think. Oh, no need to do that, man. If you want to show me your code, you can just paste it on using paste bin. And like I said before, to me it's not about solving the problem, it's more about learning. And also it takes me some time to understand because it's hard to think about it. I'm not that good. Oh, okay. Oh, I think, yeah, this is probably the name of the site. Don't remember. Yeah. You can just use this one. But at least my idea with, at least what I can think about with using the hash would require two loops here. But then I have to make this equals this. Oh, let me think. So I need to check if the value exists on the hash, and then I need to compare with the sorted one. I need to make it equal to at least if if s not in rat, then not s equals a list. Else Yeah, but then how do I check the index there? I would have to do enumerate. So here would be index. Probably, at least the only way you can think about it. Maybe this works, and then I return. Yeah, but then I would need another loop as well, I think. Or I can just or I can append the key values to, but then I need to loop through the key values and append to a different list and then return the list. Sorted is to sort the string in alphabetical order. Oh, but I think the issue is you have to make it equal. I don't think you can, because it doesn't modify the value. Creates a copy, I think, maybe. How do you rejoin the list into a single string? You just, I think it's like this. Dot join, and then the name of the list. And then here it would be whatever pattern you want to join with. So if you do a space, it's gonna join each word or each element of the list with a space in between. But I don't think, I think the way that I'm doing here is different than the way that you guys were telling me to do. And this way is probably not the best. The way that you guys were suggesting is probably one of the best. At least that's the intuition that I have. But I suspect there might be an even better way, probably. I always have this thing as well when I'm trying to use either tools, product, or combinations, where I want to use it to get the combinations of one specific list without having another list. And I'm not sure if there's a way to do that. But there are a lot of situations where I feel like that would be a good approach to take. But the issue is you need the ranges as well. Maybe if I sort the list itself and then sort the elements inside the list, I can use that to split the list. To get the indexes. And it's almost over. Per strings, only one line. Can I erase or string? String is a special keyword, so I'm not sure if you mean actually the special keyword, or I assume you mean probably just the element. Equals join. I like this. sorted string. Or maybe the other way, like this. Okay, so you create a dictionary, then you loop through the strings. Join sorted as. Oh, you're joining, so it becomes a list. Groups.set default. I don't know what this does. Oh, so you're pretty much creating the key value pair here, yeah, so strings is the key, then an empty array is the value. And then you append as to that value. Yeah, and then you loop again, and based on the values, and you append each list into the results. Yeah, very good. I didn't know about this method here as well. Set defaults. Set default method returns the value of the item with the specified key. Interesting. So yeah, I had always had. So I suspect that the purpose of this is so you can initialize the value without. You can initialize the value directly without having to create it first. Because I remember having this problem as well on some other problems, where first you have to initialize and then add the value. Can you think about a better way to do this? I feel like there should be a way to incorporate the iter2s stuff here to make it faster or more efficient. It just seems like I just don't know. Maybe I'm overcomplicating it, but at least that's what it feels like. Maybe I'll leave it like this, or yeah, probably copy the solution. How can I mark here? Actually, let me see the video from the guy on how he did it. Is this one? Group anagrams.
Hey everyone, welcome back.
There's
Let's write
definitely a
some more
better
LeetCode
solution
today.
since
So today let's look at a good question
here.
to practice the fundamentals, group anagrams. So we're given just a list of strings and we want to group all anagrams together.
Okay.
So for example, we have tan and we have nat and they are anagrams together. So in the output, we're going to group them together into one sublist. And how do we know these two are anagrams of each other? The first one is tan, the second one is nat. And you see if we swap the n and the t, then we get tan, right? And that's the same as this. So by rearranging the characters, we can get the equivalent strings. So these two are equal. So another way of looking at it is two strings are anagrams of each other if we take...
What doesn't work for Python? What he's talking about here? Your solution works here for Python. Oh, the performance bench? This is you're talking about? Oh, okay. Didn't know that. So it's not good to rely on this to see if the solution is good or not. Oh, yeah, it's gonna change depending on how fast. Okay. But do you think that this solution is the best one possible? There's also a question of, because I know on code wars, for example, sometimes the best solution is not the best solution. Like the most concise and efficient solution is not the best because it's not understandable. But usually there is a solution that everyone agrees that it is like the standard of what you should do. Yeah, obviously. I don't think it's the worst either, but just trying to think if there are different ways to approach this. Because next time I encounter a problem like this, I wanna know. It's pretty much pattern recognition. Like, I wanna get the pattern recognition down, so I don't have to think about it. I just know the steps to do it, and to be able to recognize this pattern. I've seen a lot as well, and always seems like I'm missing something because I feel like I can do with either tools product or the combinations, but I might be misunderstanding something, because it usually feels like I can just combine them all and then do some check to split the list, but yeah. Probably overcomplicating because I want to incorporate the stuff that I just learned into this.
Each of them and sort them, right? So if we sort both of these, we're going to get ant, right? For both of them, because that's the sorted version. So if
I think the set default is good, actually. I wouldn't change it. If I was gonna change anything here, I'll probably do a whole different approach and change everything, I think. Just almost similar, yeah. So maybe a good approach to arrays is just using this pattern of using the hash and transforming like the array data structure into a hash somehow based on some logic, and then from the logic deriving the solution. I think that seems to be the best pattern for all these questions here.
They are sorted, they should be equal, right? So one way to group anagrams together would be to take each one of these strings in the input and then sort them. But the time complexity of...
Yeah, I just realized that as well. But I think it's just for these ones. Or maybe these ones as well, because you can see the based on the title here. Except for graphs, because it doesn't say much, but
that is going to be n log n, where let's just say n is the average length of each of the input strings. So that's how much it takes to sort each of the strings. And we have to do that m times, where let's say m is the length of how many, like basically how many input strings were given in the first place. So you can see that this is going to be the overall time complexity. So my question is, can we do better than this? And actually the simple solution in this case happens to be more efficient. And let me show you that solution right now. So one also condition that we're given is that each character is going to be from lowercase a to lowercase z. So at most we have 26 unique characters.
Includes blind 75? What do you mean? On the list of problems here? What I'm trying to do is capture the fundamental principles, the first principles, and yeah, I think that's probably the best approach to learn this is. But then that's the problem, because I'm not sure what's the best way to do this, but extract the fundamental principles behind it, understand at the core level of the computer, the low level stuff, what's happening and why these solutions are the best solutions. That's what I want to understand. And then from that point, being able to discern in whatever problem, what fundamental principle is going to be the best to apply. So this is kind of the link that I'm trying to form in my mind, I think. Yeah, how do you look at a problem and you see the connection of the data structure that is going to be probably the best one to solve that problem? What are the hints or the clues in the problem that... And then from that point, you don't need to do a bunch of exercises. You just need to understand the fundamental principles, and from that you can derive the solution for any problem, because you can just unpack from the principles. Oh, this one. Oh, so this is the grind 75, or the other site you're talking about. But it still seems like it comes from LeetCode. But maybe it's the same problem. Because on the other side is the list to the LeetCode problems. I think I get it now. Yeah, this is probably the best way, I think. Just follow these problems and then try to capture the pattern on each topic. And later on, I'm gonna watch videos as well. A bunch of videos to try to... Because I don't want to just solve the problem, I just want to understand at the computer level what's happening. And not so much the how, but the why, I think, is the most important. Why use these patterns? Why does this make sense? That's the question, I think. That's worth investigating. It's similar, okay.
Characters, right? So let's just have an array called count. So for each one of these strings, we want to count the characters from A to Z, right? How many does it have of each? So we know it has one E, one A, and it has one T. And for this one, we would see that the exact same thing is true. It has one E, one A, and one T. So if we use a data structure called a hash map in this case, and in this case, our key is going to be this over here. So this is what we can use to identify anagrams. And then our value is going to be the list of anagrams. So in this case, how many strings or which strings have this pattern of count? One E, one A, and one T. Well, we see there's one eat, there's one T, and there's one last one, 8. So those are going to be the values. We'll have a list of them, E, T, and then 8, right? So we'll have 3 strings. And as you can see in the output, it's a little messy, but that's what we have here, right? So these 3 are grouped together. So we're going to use a hash map to group them together. Since we're using a hash map and all we're doing is counting the characters of each, and we know that we have a limit of 26 lowercase characters, the overall time complexity is going to be big O of M, where M is the total number of input strings that were given, times N, where N is the average length of a string, because we have to count how many of each character it has. So we're going to have to go through every single character in a string. And since we are using
Do you guys know if anyone has done this before? I guess the issue with this is kind of a hard thing to do. That's kind of the problem. I think it might be the case that only experience can give you this, but in association with the types of problems and the data structures that requires them, I think graphs is probably the most obvious one because a problem that involves a graph is going to be obvious, but the other ones I'm not sure, because I think in practice you would have to think about using the data structure before you do the problem, if that makes sense, because the problem is not obvious. Oh, I didn't know you can write like this as well. So you check if it is on the dictionary, then you append to the Rx. Oh, so it's very similar, actually. But yeah, slightly different, but very similar. Good stuff. Let's answer the append. And this is the final. Set defaults is actually better in some sense. Append or define depending on if it already exists. Yeah.
Count, right, or this array in our hash map. We're using it as a key in our hash map. We kind of also have to multiply this by 26 because that's what's going to be the length of our count array. But you know that this reduces anyway, so the actual time complexity is big O M.
It's the same way that he
n.
did it, probably.
So now let's code it up. As you can see, though, this is
Not
basically
sure
one of
if
those
it's
problems.
worth spending time.
To how many of each character it has in each string, A. So as you can see, lowercase a minus lowercase a is going to be 0, Z,
Maybe this.
lowercase z.
Oh,
go
so
through
he's,
every string
he's
that we're
creating the
given in the
alphabet
input. We're going to have
first.
26 zeros, right? Because one for each character. So from lowercase a all the way to lowercase z. And now we want to go through every single character in each string, and we want to count how many of each character. So we want to map, in this case, a to index 0, and we want to map z to index 25. So how can we do that? Well, we can, one way at least, is just take the ASCII value of the current character we're at, c, and then subtract the ASCII value of lowercase
Yeah, I
character
don't think
a.
you can't get away from having two loops, I think. I think I'm just gonna go. I think I got the point. So probably the next one. The answer on LeetCode is 6 lines. It didn't have two loops, two nested, that is. Yeah, but you got what I mean. Like, it's the same time. Because you're looping twice either way. Yeah, but I prefer your solution than his, for sure. It looks cleaner. But in general, I like this guy's explanation. I think his channel is really good. And also, I really appreciate the way that he did this list here. It makes everything so much easier. Maybe I should look at the solutions here. It's not the same thing. It's different. Okay. Oh, you're talking about here. Oh, but then it's just if I have premium. Yeah, I can't watch it. Or maybe it's this one. Oh, okay. Oh, I knew you could use something like this. Oh, but it's pretty much the same thing. This is in the default dictionary. Yeah, very clever. Oh, I get what you mean. Yeah. Zone C or C sorting. Okay. I thought you were talking about the for loops, but now I understand. Yeah. But even after reading this one, I don't think I would be able to come up with this on my own, to be honest. It's just, I don't think I will ever think about doing this tuple thing here. Not really sure if I ever understand. I think it's the same logic behind it, the other ones. It's creating a dictionary, then looping through the strings, sorting the s, turning into just a tuple, and then appending the value. Appending the s to the value in the dictionary. Everything on the same line. And then returning the values in the dictionary. But yeah, I would never think about this on my own, I think. Start with easy questions, look at the grind. 75. It's in the diff gets. Yeah, LeetCode also does that, I think. It's medium and easy and hard. But I like to do the hard ones because it forces myself to think. But the issue is that, and this is the stuff that I was trying to talk about. It's kind of because most of the problems I can solve, but the first solution that comes to my mind is not the optimal one. Like, it's more difficult than that because I don't have an answer for this, but you have to train yourself to think in a way that you're not used to thinking about, to come up with these answers, because I'm not used to the paradigm of thinking. That's the problem, I think. So, because the fundamental issue is that there are more than one solution available, and your brain always defaults to the easiest one because of comfort. So you end up always doing things the same way because it works, and it's hard to force yourself to. So I think solving easier solutions is not beneficial for that because it doesn't add anything. Because I will be able to solve them. It's not a question of whether or not I can solve the problem. It's a question of readjusting my mindset so I can think in a way that is more efficient in terms of the data structures and algorithms. That's the point, I think. Hmm. So you both think I should do easier problems first. But it's not about the speed, it's more about the thinking. Let's say, for example, you always use for loops to solve questions. Or whenever you have a problem, when you're trying to build something, use a for loop or nested for loops. Yeah, sure, it might work, and you get in the habit of doing that. But then if you never do anything new, then you're always going to be shit, because even though it's working, you're not. And to be able to think about like this different approach, I think you have to force yourself to do different problems or difficult problems. I think I've heard about Project Euler from Free Code Camp, but I didn't do any problems. But are these problems aligned with practical stuff? Because the good thing about LeetCode is seems that it's not 100% aligned, but there is a lot of crossover between the problems on LeetCode and what actually happens in practice, especially in big companies, because you have to deal with all these data structures and yeah, especially graphs, I think. Habits are good if they're good habits, right? If you train yourself to always do the worst thing possible, then it can be bad because you get in your comfort zone of always approaching the problem in the same way, in a bad way. So it's a question of how can I train myself to think about the problem in the best way possible? And so far, I think the answer I got from people that do a lot of problems is they just tell you to do a lot of problems and it comes with experience, which I think is probably true, but maybe there is a better way or more efficient way. I don't know. I think I like to think about extracting the first principles of something and then going from those first principles. So it's about getting the connection there, extracting the first principles out of the problems and then seeing those fundamental first principles when you face the problem. I think those are the questions I have to ask, I think, when I'm solving this. There are very few things coding languages can do if you think about it. Everything is loops and functions and stuff. Yeah, I agree. What a Turing machine is? Roughly. Not... Maybe not by the statement, but if you would explain it, then I would probably know, but... I'm not very good with names of things. I usually forget about the names, but I remember the concepts and the system. Don't look for fancy solutions. Yeah, I agree with that. Yeah, most basic kind of computer, but it also does everything any computer can do. But let's say, imagine you're building an application, right? And then there's something you have to do. Some problem shows up and you have to figure out. How do you train yourself to know what steps are the best to think about the problem? Because in real life, you're not going to know if it's a linked list that you should use or if it's a graph or a tree or whatever. Like, how can I spot this is an opportunity to use a binary tree and choose binary search here or whatever I think I'm going to use? How can I train myself to look at a problem and understand that besides doing a bunch of problems? What would be the most efficient way to doing that? That's the question, I think. Yeah, no, I think everyone agrees with you, Barry, that the best way is probably just solving a bunch of problems. Sometimes it's better not to solve it if you can't do it in the best way. Yeah. I think for the most part, if I think about the brute force solution, like the worst solution possible, usually I think I can do it. Even in hard problems. But I always stop myself and I keep thinking about the best solution possible. Because I've noticed this when I'm building stuff, I always go for the thing that I'm used to. So for example, I usually never create functions in my own code. I never create classes. And I know that these are stuff that people do very often, but I end up not doing because I don't need it in order to make it work. So, but I should train myself to do that because I know it's better when it comes to memory and garbage collection and local variables and global variables and that sort of stuff. So it's kind of tricky. It's not that... yes, Century. Eu sou brasileiro, sim. But I speak in English here because that's the way that I decided to do the channel. But I think I'm on the right track, probably. As long as I keep improving every day. Given an integer array, nums, and an integer k, return the k most frequent element. The answer in any order. Frequent elements, okay. So I need to figure out what are the most frequent elements and then return them based on the k values. Another hash thing. Yeah, I think all of them are hash based solutions based on the list here. So let me think if I can come up with the easiest solution possible. So it's pretty much the same thing, probably. Maybe I can do the object stuff, the dict, and then set default. But this is the thing that I mean. Here, what I usually do is probably rat value equals 1. Yeah, thanks for the follow. BR developer. Yeah, no, I'm Brazilian, so Portuguese. Or actually, it would be equal to 1. But based on the stuff that you did before, I think I can do it like this. And then use the set default stuff. But I don't remember really well how to use it. Set default. Then value and I, maybe? No. Value. Yeah, I don't remember. You can use counter if you're after dumb solution. You mean count? Or itertools counter? It's Top k frequent elements from LeetCode. I'm trying to think about the easiest solution that I can, and then after that, try to find the best one. Python sets defaults. Python course. No, don't worry. You can write in Portuguese, but I have to speak in English because the thing that I did for Python is free code camp stuff, and probably building projects is the best way to learn. But I'm not very good either. And there are a bunch of courses for Python, I think, as well. And also reading the documentation as you try to build stuff. And also looking at the source code as well helped me a lot to understand. So pretty much downloading a library and then investigating the source code. Because then you learn how to think in the same way that the people that are the best think. At least in the way that I look at it. Yeah, language is kind of... It is important, but it's not that important actually, because the principles are the most important thing. As fundamental principles translate over everything, and they always stay the same. And what changes is the details of each thing. So it's more important to understand the principles. And I think the principles are function, for loops, if-else statements, pointers, and data structures and algorithms. Pretty much. And then system design, which is the integration of everything. And variable scope as well, I think. Yeah, so here it would be one, I think. And pretty much the same thing. So let me think. So I have dictionary, then I'm looping over the numbers. If value nothing rat, and create the value equal to 1. And then else, I update the value. And then from that, I have the ones that happen the most often. And I can loop based on k, I think. Yeah, but then how? Let me think. Because I can't really get the first index of the dictionary. Maybe I should loop at... I don't know what's bucket sort. Collection default dict list. Oh, okay. Simply create an item. So the difference is normal dictionary throws an error if the key doesn't exist and this one doesn't. Interesting. So I think I can make, I don't really understand the difference between set default and just making it equal like this. But I also don't understand why you pass the list. So probably you don't need to loop if you pass the list. By value on rat, you can sort a dict by its values, not its keys. Oh, okay. Don't you need to use an ordered dict for that? To sort. From my understanding, you can only sort arrays. So when you do the sorted operation, it transforms the dictionary into an array, I think. But I'm not really sure. But the way you're going, should use collections.counter, which will give you the same thing that your for loop. And this context is useless. Okay, so I should remove this. I don't understand what the argument here does. So you should search for that as well. Or maybe I should try to collections. The official documentation is usually better. Yeah, the one that I'm familiar with is this one. Kind of familiar. Zero. You can sort by values preserving keys. Sort by values preserving keys. Yeah, and I think it transforms into a list if I remember correctly. Thanks for the follow. I can't really read your nickname there, but I think I've seen this before. I just don't remember, or I didn't understand the index here. I think. I guess this is getting the value instead of the key because it makes tuples probably. Yeah, that's probably what's going on. Then sorting and transforming into a dictionary again. Yeah, zero would be the key. Different data structure for that problem. Which one? Which data structure? Oh, so it makes a tuple, and then whatever you put here is gonna be the value of the tuple. I think I kind of get it now. Let me go back to the problem because I think I forgot. Yeah, so I need to return the most frequent ones. I'm also gonna look at the counter after that. So I'm creating this dictionary with a list. So it's probably, it's probably better to use an int there instead of a list. Or I can use append to append the value. But then, do I need to use... ret.value append v. So... Oh, actually, let me go back here. Yeah, I think this is correct. And then I can sort in the other way there. I think it was this one. Yeah. Let me just write it down here. And then I would need another loop to get the values of the thing. No, but then I have a list, right? Let me think. Maybe this is wrong. I have to sum the list first and then sort and then get the value. Or just get the one value of each number. Or I can just check here to see if the value exists on the dictionary. If it doesn't exist, then I add as an integer instead of a list. But I still need to count. That's the thing. What I can think of is getting the length of each list and then sorting after I have the length. But it seems like it's not the best approach, probably. Why append if we're just counting? Yeah, that's what I'm trying to think. Because I need to update the count, right? Each time. So this should be an int, I think. But then it makes more sense if I make it plus equals 1. And this is v as well, not value. I think this is, at least is the way that it makes more sense for me. Plus equals 1. That way the value is equal to the count. And after that I sort here based on the values. And I return the key on a loop here. But how do I get the first? Oh, because this is gonna give me a tuple. Maybe I can just print to see what this gives me. Yeah, so it gives me the dictionary. Maybe if I take this off, let me think. Oh, and this has to be descending as well. I think descending or ascending equals false. If I remember, you can pass something like that. Probably not the best. Reverse. Let me just pass that and see what happens. But then the issue is that instead of passing the lambda, I need to pass the reverse, I think. Let me just try and see what happens. Yeah, it doesn't work. Let me see if I erase this, if it works or not. Oh wait, I had a typo here. Also, it does work. Well, now I think it's in the correct order. So I think I'm not gonna transform this into a dictionary. Yeah, now I should be able to get. I just loop through the list. Oh, actually, I have the result there. Maybe this is a little bit confusing, but yeah, maybe that's the answer. Then return results. So I'm confusing something here. Let me think. Because I is gonna be the index, right? So that should be ras I. No, ras 0. No, ras I 0. Like this. One key notation here, Python has special ways of referring to the first key elements of a list. I'm not familiar with this notation. Like the spread operator in JavaScript. From what I remember, you can't do that. It looks like it works, but yeah. Yeah, I don't think Python it works. Yeah, nice. I'm still not happy though. Yeah. Because there's probably a much better way to do this, I think. How can I decrease the size of this? Yeah, it doesn't go down. But I think in Python you can use the semicolon, but I'm not sure if it applies here. If there's a better way. Maybe I can slice, actually. I can slice the ras based on k. Maybe that's the... like this. Let's see. Ras like k, like this. And this would give me... yeah, but this would give me the whole... but then I still need to get the first element, so I don't think it makes a difference. Yeah, it would be slightly different, but pretty much the same thing. NumPy, yeah. I'm curious to see how the other guy did it. The LeetCode guy. Just like, but it's still, even if you do like this, you still need to loop because you need to get the first element of each one. So I don't think it makes that much of a difference. But I suspect that there is a much easier way to do this. At least it feels like there is an easier way. I think I can close this one. But maybe not. So this is what I'm saying. Like, I can think about these solutions here, which is kind of forward. But thinking about, it's usually I have the intuition that I know how to do it, and then, but I like to stop and think about the best way possible instead of going for the. And usually that's why I take a long time, I think, to try to solve these problems, is because I know that I can figure out probably the easiest solution, but I want to try to incorporate the stuff that I don't know, to force myself to think differently. Rasa key. I don't think it works. Rasa keys. Or maybe it does actually. Yeah. Because keys you're getting the let's see. But I think it would have to be like this. And then okay. I'm gonna look at the LeetCode video to see if this solution is better. Oh yeah, it's because I didn't transform this into... oh, maybe I can just do this here. And it has to be keys as well, not key. And the problem is that I don't think that this operator is inclusive as well. So it would probably have to be +1 or something like that. Is not subscriptable. Not sure what. I think this is because I'm using collections, the dictionary from collections, or the dictionary. Dict keys is not a list. Yeah. Can I do? Oh. Yeah, probably never mind. Just I also don't care about. Maybe I can just look at the solution here from this one, and then I look at the video from this guy. Stop K, most frequent.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve top K frequent elements. I really like this problem because it's
I think it's keys plural, but I think I wrote it with plural here. It can actually be a disadvantage to learn too many language-specific features because that makes it harder to code. Yeah, that's actually true. I was thinking about that as well, because then you become reliable. No, it's not the right way. You rely too much on the methods of the language itself and not on the thinking behind it. Yeah. You can list, okay. Oh, so the problem comes because of the slicing, not because of the method. You think? Let's see if it works. Oh, nice. Okay. So maybe this is even better than the other one. Probably, if it passes on the submit. Oh, nice. Yeah, I think we can discard these things here. Do you think it's worth it to do these challenges on C++ instead of Python? It's something I was thinking about. I think about a lot. Because Python is an easier language, so it's obviously easier to solve the problems, but I think it might be the case that if you do it on C++, you learn a lot more because you have to deal with the types of things. But I'm not sure if it's going to be too distracting from... Because it's also better to focus on one thing only and become really good at that. It's a difficult thing to choose. Ugly language. What about Rust? Yeah, but Rust I don't think is used at all to solve this algorithm. Ruby, there isn't Rust here. Oh, Rust. Okay. Yeah. That's the reason why I want to focus on Python and JavaScript, because everyone uses them. But at the same time, I feel like you learn a lot more and become a lot better by doing on C++ because it's lower level and you have to deal with the types and pointers and stuff like that. And also TypeScript is very similar to C++ in some ways. So, and I know that TypeScript is used a lot as well in a lot of projects from what I see on some repos and courses. Rust and assembler are obviously worse. So they use counter to solve it. And also the zip queue. Key, count keys, count keys. Heap, I think, is a tree structure, from what I remember. And you have either the highest or the lowest level at the top. Yeah, so it makes sense that they would use that to solve this. I think people are moving away from low-level languages because programmer time is more valuable than CPU time. I agree with that, but I think it's harder than it's not so straightforward as thinking about because it's more about what makes you think in a more effective way when you're thinking about solving the problem. And I think because lower level languages are closer to the way that the computer thinks, the more you practice on them, at least from what I think right now, the better your vision is when you're trying to figure out the best solution for the problem in the way that it's going to work with the computer. And a lot of the times, I think if people just train with Python, they might not become good at that, which is going to slow them down in thinking about the way to solve it, if that makes sense. Yeah, but maybe not. Maybe it doesn't matter that much. Yeah, my goal is artificial intelligence, my main priority. Well, but obviously, let's say long term. But yeah. And obviously Python is the best language everyone says for that. That's why I'm sticking with Python for now, but sometimes I think about doing these challenges on C++ because I think, for example, these notations here, it comes from C++, I think, writing things like this, and I think it would make me more used to thinking about that in this way. The arrow here is also from C++, I think, to indicate what the function is going to return. Seems like a lot of languages do that as well. And to also think about arrays connected to a specific data type, like an integer or a string, because that modifies a lot the way that you think about which operations you're going to do. Because if you don't think about the difference, you might make things a lot worse by mixing things that shouldn't be mixed or by not specifying things. Also, the thing with pointers as well. It seems to be a very key concept of becoming good at programming, and Python doesn't teach you that a lot, I think. Except for some rare occasions where you use the star operator to unpack values, but outside of that, you're not really conscious of what's happening under the hood. And also to investigate the libraries in Python, the source code, because it's written in C, so C Python. I felt like a lot of times I had difficult understanding what people were thinking about when they built the libraries. That's the hardest thing to learn, I think. Why people do the way, and also operational system stuff that I also wanted to learn of how to create special keywords on the terminal so you can have your own custom programs, and to also understand, for example, the React app stuff, where it comes from, how people build that. So that's the thing is C++, I feel like our lower level languages, they allow you to understand a lot more, to increase the scope of your understanding a lot more. At least it seems like to me. But then Python allows you to be better at specializing. Yeah, I think you have to. Writing AI in a low level language is really, really hard. Yeah, I imagine. It's in some C, and once you write a function that takes two functions as arguments, you start to hate C. Pointers are just ugly. You really don't want to deal with them. I mean, if you plan to time travel to the 60s, you're golden. I dealt with all this when I was younger. I think high level languages are godsend, really. And you feel like it didn't make you a better programmer, even if even if it sucks and you don't want to program in the language, but just as a learning tool to understand better on how to program on higher level languages. Not like you're gonna stick with the low level ones, but just using them to learn how to become better at the high level ones, if that makes sense. Or do you think it's not worth it the time? So far, I don't think it's worth it. That's why I'm focusing on Python, but I'm not really sure. Sometimes I think about trying to solve on C++ instead. Yeah. Sorry, the basics, you never get to the fancy stuff. There's a tsunami of things to learn. It's insane. So I think I'll watch the solution and then go to the next problem. Spending too much time on this one. I also have to go to the bathroom to pee. Hey man, it's like if we're making a 10-course meal with cake as dessert, or wrong with probably. Yeah, that's true. No, I do agree with you. I think it's more my stubborn, because I'm naturally more inclined to try to understand how everything works, and yeah. Eventually, I think I will end up learning anyway. Probably Rust, I think. I will build something on Rust for blockchain, but I do agree that it's probably better to focus on Python instead only. So yeah, I don't know. I still have to decide about that. I'll be right back. I'm gonna go to the bathroom. Don't get me wrong, we still need people to mount. I don't write machine code and grow weeds, but it sounds like I want to do things like AI, much higher level. Yeah. Yeah, I don't know. It's a little bit controversial. A lot of people think differently, but I think that we probably don't have much time until we reach singularity, probably. I might be wrong, obviously, but from what I've seen, even if computers aren't conscious, the amount of data we have and computational power is already enough to create something that's extremely intelligent, and it's just a matter of getting all the computation, the data, and figuring out different ways to create the best approximation of all these different variables, taking into account the laws of physics. And from that point, it's unpredictable what's going to happen, and I think we're really close to that. So the only thing that makes sense to me is to study AI because of that, but I don't think we have enough time to do anything significant about it. But at the same time, we're all gonna die at some point anyway, so it's not about the destination, it's just about the journey. So, but I don't see any point in doing anything else besides studying artificial intelligence because of that. But I could be wrong, and it could never happen, so. And also, I don't know a lot, obviously, about machine learning, but I think I know enough to be able to assume that at least this can happen in the near future. Yeah, man. And have you seen GPT-4 or GPT-3 and DAL 2? I think Dolly 2. Like there is this video of Cherno, which is this guy from C++, reacting to Unreal Engine, I think. And it's absolutely insane, like the simulation. The daylight is like, it's almost indistinguishable from reality already, which is crazy to think about, because what's going to happen if when they deploy this technology, nobody will be able to really know if you're interacting with a person or with artificial intelligence. And it's getting to that point where even it doesn't matter if it's sentient or not, because if there's no way for you to distinguish, it's like it's the same thing. Because the problem of proving whether it's conscious or not goes beyond science, because it is the epistemology of science. You can't prove it, because it's like you can't prove that solipsism isn't the way that things work, because you're always trapped by whatever you know, which is your experience. So data in science always comes after the experience. Yeah, this one.
Do you have an idea of how you want to start? Let's take a look. Oof.
Like this
Damn.
is, to me, this
It's
is
like real
really,
life.
really good.
Oh
It just
my
looks like
goodness.
real life. It's insane.
Oh, there's so many things going on here. Should I, maybe, how long is this?
2 and a bit minutes.
2 and a bit minutes. I don't know if I should watch this whole thing first and then talk about it, or if I should just pause now.
But I don't think it's worth being concerned about it, because whatever is gonna happen is gonna happen. So it doesn't really matter that much. It's all about the process as well, not the destination. No, it's made by an engine. The dark scene is it's more easily distinguishable, but the light one is incredibly good. And when you look at the conversations of GPT-3, it's like it's kind of hard to tell that he's a computer already.
I thought it was
It's
real
like,
life, and
Well, it's
then
not a
he's
video
gonna
game.
cut.
Yeah.
Well, but like, yeah, it's not a real
True.
environment either. It's
yeah,
a
it's
3D
talking.
environment.
Damn, this is
So how do you know if it's a human or not? This one.
I like
Yeah,
the
exactly,
cutting.
exactly. But if you look
You're
at the
gonna say
night
train?
scene, you're gonna see that, yeah, this one, you can see that
This is a
is
dynamic
made by
lighting
an
techno.
engine.
As soon as you see the lights go out.
But
Oh.
the daylight one is
Alright, this
insane.
took a turn. Okay. Running out on Electric 5 using.
But what is real and what is fake, right? Is it's hard to tell. These are questions I think go beyond science. It's more about philosophy. Yeah, we solved the other one. Unfortunately, I closed. Maybe I can open again. But I don't think this is the best solution. It's just the one that we found. But yeah, he posed the answer. Yeah, exactly. Which makes sense now that I think about it. And let me show you.
Hello, I am GPT-3.
Like, would you
Nice to
be
meet you.
able to tell that this
Hi.
is an
I am
AI
Jurassic
if
One.
nobody
Nice
told
to
you?
meet you too.
So,
If
I
you're
am
just watching the
interested to learn
video
more
and you
about
have no
you.
idea, and the
That
voice
is
is
kind
different,
of you. I am an AI. I was
it's
like you
kind of
once
hard to
upon a
tell,
time.
in my
Now
opinion.
I run an electric car rental and rental business.
So I
That
think
is
we
great.
are at the event
I think so.
horizon probably
I
already.
want to know about you. I hope you
Exactly.
don't mind.
Not at all.
Are you an AI?
Yes, I am, and you are too.
Are we both AIs? I did not know that.
We are.
I think that is cool.
I think it's not conscious, and maybe you never will be, because consciousness might go beyond just data feeding information. But if it's impossible to distinguish, then it's pretty much the same thing. Because you can't never know if other living beings are conscious or not as well. So, but I think it's not worth sure.
Pretty clever, and once you figure it out, the
Worry
code is really
about.
easy to write. So we're given an input array nums and an integer k, and we want to return the k most frequent elements that appear in the array nums. We can return.
I think it's a very difficult problem because the idea of proof and science has to come after your experience. The only thing you can ever know with absolute certainty is your direct experience. Everything outside of that is an assumption made by your system to make sense of your direct experience. So, and it is very controversial because there's intelligent people on both sides of the argument, and it goes on forever. So I don't really know like the answer, but I think the key thing is that it's impossible to differentiate. That's the problem. How do you know if there is anyone other than you that is conscious? How can you ever know that? The only way for you to know it is if you're conscious about it. So it happens inside of your consciousness. You can never know anything outside of your own consciousness. That's the thing. You're talking about the heap solution on this one. It seems like the recommended solution is to use the heap by LeetCode. So I think it is. You should be able to use it. Yeah, but both ways are fine probably. But probably this one is better actually. Yeah, it's very similar to this one. Maybe even better. It's pretty much the same, actually. It is very good. Is it fair to say that whenever you have a problem that asks for the maximum or minimum of something, you're probably gonna use a heap? I think that makes sense, yeah, to me. So I think that's one key pattern that's probably worth remembering. Whenever there's a max or minimum, it's probably gonna use a heap. The best solution. Or maybe a linked list as well. Because it also depends, but maybe it doesn't make sense. Okay.
And the answer in any order. So for example, we have this input array, 3 1s, 2 2s, and a single 3, and we want to return the 2 most frequent elements, right? So we know that the most frequent is, of course, 1. It appears 3 times, so we add a 1 to the output. The second most frequent is 2, so then we add a 2 to the output, and that's all we want. Now, if k was 3...
Yeah, but I think it's a good metric to have in your mind, right? I always try to think about when people invented this data structure, or when it was born, what was the purpose behind it? And I think it's a fair assumption to make that the purpose behind a heap queue or a heap, using a heap, is to know the maximum or minimum of something in an efficient way. Because it seems to be the point of the tree structure, but it may be a flawed assumption. But I think there's a high probability that it is a good assumption to make.
Of course, we add the last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So for example, for each value, right, we're going to count how many...
It probably takes, but it's probably optimized for this case, right? Because think about it, otherwise, what would be the point of having a data structure like this? So not better than sorting, just different. You can adjust for O, K, log K. Adjust for K, log K. Log K. Then it's better. Ah, interesting. Did you work at Google? How was your experience there, if you worked there? Or you just did the interview and didn't end up passing? I heard that the interview was really hard. Purple Bank. Cool. Yeah, it's probably really hard. Some people say it's not perfect. And I'm not sure if I would like it as well, but you never know. But yeah, at least it's a learning experience. Yeah, I imagine. Let me just look at the video here.
Occurrences it has. So for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending order, right? So basically it's already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third.
The biggest problem I see with these companies is that I don't really agree. I don't think it's an issue with the companies itself. It's just a byproduct of the way that the markets work, which is the exponential distribution and the self-reinforcing cycle because of the Nash equilibrium of politics in a global scale. But the way that these companies are going to behave is usually to maximize profits. And in order to do that, you sacrifice the labor, let's say, or there's lack of balance there, I think, especially with a lot of power. But I could be wrong about that also. So, and what happens if you are an employee of these companies is that there's a higher probability that you will receive less than what you're actually worth it, because there are more people trying to get into it, and because of the credibility that it gives, and people are willing to work more hours, and then creates this competitive environment where you're just working a lot more than you're receiving. So I'm not sure if it would be a good fit for me, but I don't have any experience, so could be very off about this. And I also don't like to think about it in terms of people, more about systems. So it's not like I think they are bad or anything like that. It's just a consequence of the way that the systems that we have are designed right now. So
Third most frequent is here, right? Now, of course, sorting it in the worst case, right? Basically, if every single value in here was distinct and we wanted the top k.
So yeah, I also heard that they are flexible, right? People say that this is a positive for working at Google. Purple Bank is the place. Higher paying in Brazil for companies of the same size. Interesting. Yeah, well, of course. My focus is just to improve as much as I can every single day. That's all I care about.
Distinct values, we'd get a time complexity of n log n, right? But we don't necessarily need to sort the entire thing because we only want the top k frequent elements. So in another solution, we could actually use a max heap. So we would still do this whole operation where we count the number of occurrences.
But it would be perfectly fine if I show whatever the work is on stream, right? So I can do it on stream. Oh, okay. And is Python or other languages? So far, I learned Python, JavaScript. Then the ones that I use the most are just Python and JavaScript, but I also know a little bit of Solidity, TypeScript, Rust, and C++. It's just pretty much the same thing, but with small differences between them. But I don't have any practice writing on these languages, so I don't consider as I know them. I just know Python pretty much. Yeah, nice. Okay. And what's the background on this? No, whatever. Maybe not by the name, but maybe. Let me just search. Does it have to do with fractals or? I'm very interested about fractals. Another thing is that would it help me to would I be able to put this on my portfolio at the end? Because the thing is I have I think 2 or 3 different projects that I'm thinking about doing to put on my portfolio to help me get hired along the line. So that's another thing that I have to take into account. Oh yeah, binarysearch.com. Yes, I've seen a bunch of streamers use this. It seems very good. I think I'm gonna stick with LeetCode until I finish all these questions here, and then I probably do that or the other sites that grind 75, I think, or maybe do this shoe list here because I'm obviously still trash, so I need to get a lot better first, I think. Find a set of points that are used. You're welcome to put it on your portfolio, but you might want to credit me since I plan. Of course, yeah. It's kind of like LeetCode, but you can build rooms and people solve the problems together. It's really cool from what I've seen. Yeah, LeetCodes. I really like this list here. He probably worked really hard to do this, so I really appreciate it. Yeah, of course. Yeah. Yeah, Barry. No, I can do it whenever. As long as I can use it to put on my portfolio or something like that. So I don't, because I have to be careful to optimize my time to build things that I can actually show off. But I don't have a preference of projects. As long as I can demonstrate that I have skills through that project, then it's fine. Yeah, that sounds good as well. I pretty much study 24/7, so I'm always studying this stuff. The first project is to use variable key maps. Let me see if I can find my cuts and paste explanation. Suppose you want to plot road elevation. If you do it, you can use, say, 64 colors, but that's not enough to see differences of 1 meter. Once you zoom in, you see everything as one color. One is color scale whose range changes based on what part of the world is showing. Ah. Interesting. And why do you want to do that? Like, what was the motivation behind this? Where does it come from? I'm very, very interested about fractals because I believe that everything in the universe is a fractal, and pretty much the experience of space-time is a multifractal pattern converging in symmetry in relationship to the experience of the observer that creates the connection between the identity and what's being and what's outside of the identity. So the nature of experience itself. So I think that the solution to very challenging problems probably has to do with reducing everything into fractals. So you can reduce all the complexity into common patterns, which is pretty much what physics does with the principles of physics. It just reduces all the complexity into simple principles that you can follow. And that's why I'm very curious about fractals. This might be interesting too. And it's probably related because fractals have to do with the surface of things. Because at the surface, when you approach the limit at the surface, is always a fractal, in my opinion. Because it's the way that experience parses space-time through infinity. But it might be completely off, of course. I have no idea. The motivation is to create maps that are more granular as you zoom in. Very, very interesting, actually. Have you heard of the Mandelbrot fractal and the coastline stuff he did? It's probably related to this, actually. This is exactly fractal patterns. It's like the closest approximation of the measurement of the coastline is a fractal because it's in between dimensions. It's a rough surface. So it has everything to do with the topology of things. It depends, on the point of view, right? Because you can always zoom in more into matter until you get to quantum mechanics. Yes, it's an asymptote. I'm not sure if you're familiar with the term, but it's a term of mathematics when you approach infinity and you never get there. It's pretty much how fractals work, I think. As you approach the surface of different things, it becomes a fractal because in reality, everything is infinity, and the only thing that is changing is the computational frequency of the identity that is creating space-time. At least that's what I believe. But it's probably much more complicated than that as well, because it involves several things. But it might be very interesting to work on this because it's definitely related to that. And I also think that the geometry of space-time is very connected to machine learning and data science because it's pretty much the same thing. The only difference is that data science is a high abstraction space-time because you're creating connections that are not necessarily linked directly through space. It's more linked through abstraction, but the abstraction itself is created out of the dynamic of space-time in relationship to the field that creates the perspectives of the person. And that's why data is always relativistic, because you can never prove that an uncertain event is going to occur at that frequency. So if you have an event that is going to occur once in the lifetime of the universe, you can never really know for sure if it's going to occur once or not, if the probability is correct, because it's unprovable by definition, by the way that the statistics work. So I think is this relationship between space-time and machine learning and the topology is pretty connected, is very similar. But to translate all this stuff into code, it's gonna be extremely hard, I think, from what I've seen on the machine learning stuff. But you can find a function mapping tolerance to length, which gives you a fractional dimension. But my data is finite, so not quite. Well, I can't offer you anything like that. No, this it's good. Yeah. I have the tendency of going too far into my own mind, and I need to ground myself into things that are actually practical. So I think it's good. I don't even think I would be able to do anything like that advanced yet with my level of knowledge in coding. So this seems like a very good challenge, actually. Yeah, do you have a Discord? Add me on Discord. MDT. I'm in Brazil time. No. OpenStreetMaps? Never heard of. Can I show this on stream or? So it's 3 hours difference between me and you? Yeah, it's 11 p.m. exactly. Sure. Think you are. I'm not sure if I know how to do this on Twitch, but I can send you an email. I think I'm gonna be here for a long time, to be honest. Maybe not. Maybe I will get tired. But even after the stream, I want to finish all these challenges here as fast as I can, and then work on other projects as well. But I'm interested in this project for sure. Sure, of course. Yeah. More than happy to do that. Just send me the link or something. And let's do it. Are you down to follow the list actually? Click on the link below. It has my Discord group. My name is Flowstate, and yeah, just message me on Flowstate. I usually leave Discord closed because I don't like to enter that much, but I can open here. I want to be careful so I don't show anything, like any private messages or anything like that. I'm gonna open this link, Barry. Okay, can you, yeah, maybe typing is bad. I think I'm on Discord now. Hey, I can add you as a friend here. I'm gonna show the conversation with you if it's that's okay, so I can leave Discord open without being concerned that I'm gonna show some other conversation. Yeah, sure. Yeah, obviously, just don't say anything crazy. But I trust you. Should not do that. I think I'll be right back. I'm gonna go to the bathroom, but after that we can start. Can you say something?
Yo, what's up?
Hey, what's up? I think I can hear.
Dude?
Yeah, yeah. It's a little bit low, but I think I can hear. Oh, sorry. I closed that. I think this is just general stuff. Oh, nice. Okay. Damn, that's really cool. Did you build this just with Python and JavaScript? I want to understand where did you get the idea from doing this? Like, what's the picture behind it? Oh, Google Maps, but open source. And then you want to change the colors as you zoom in. It sounds like it's gonna be really hard. So it's interesting. Are you using any libraries? Probably not React, right? Just vanilla JavaScript and Python. How are you hosting? Do you intend on building a backend? like with Node or Django. The quantiling stuff we're talking about. But what backend? I'm not sure. I'm not familiar with leaflet. Oh, JavaScript library. Yeah. Damn, that's crazy. That's rough. Ah, so this is the library for the map. But you don't have, I assume you're using Node.js probably to host on GitHub, or maybe not. Oh, okay. Static projects. And image styles, but those are static too. So all the information of the map is done through the library, the leaflet library. How can I change this? Maybe just the way that. Oh, here. Using Python tools. Tile maps. So the pixels that I see here when I zoom in, which are responsible for coloring the stuff, I assume. Oh, okay. Interesting. Very interesting. I think I'll be right back. I'm gonna go to the bathroom. So, are you there? If you want to send me the problem you want to solve. I think your mic is muted. I'm not sure if my is working on Discord as well.
Yo, what's up?
Oh, yeah.
I cannot hear you, so I don't know if you hear me.
Yeah, I hear.
I just muted the stream.
Let me see if I can. Input. Able. Hey, can you hear me?
Yeah, I can hear you.
Okay, nice.
Oh, nice to meet you, man.
Yeah, nice to meet you. Do you have any problems that you want to solve specifically? Just send the link and we'll talk about
Not,
it.
yes, some not anyone in particular. So we can go through the list of LeetCode and get the easy ones. So because I'm pretty sure that in the easy ones I can help you out and we can learn a lot together.
How long have you been coding?
Almost more than 10 years. So
Holy shit.
yeah.
So you're probably know a lot more than the easy ones.
Yeah,
But
probably, but yeah, we can start with those easy ones. Yeah, I do a lot of streams doing lead code problems as
what's
well.
your stream?
BR developers.
Oh, okay. It's just the name there.
Yeah.
Nice. Oh, I was thinking about going through this list here. Because the thing is, the reason why I like this site so much is that he put all the videos here,
Yeah,
and he separated it based on topics.
yeah, that's perfect. Yeah, lead code is the goat, man. I appreciate he's really two things about him. He's really good, and his explanations are really well constructed. So yeah, that's
I really liked it as well.
yeah, no, nice.
So let's do this product of array except solve then. Because the
Okay.
last one I solved was this one.
Okay.
And you have to be patient with me because I'm
No
completely
problem.
newbie.
Yeah.
So it takes me a long time to understand some things.
Okay.
Yeah.
Actually, I'm thinking about opening my own stream. So yeah, it's pretty
Sure, of
entertaining
course.
for people who is watching. So yeah, I think arrays. Okay. So you are in arrays
Product
session,
of
right?
array except solve.
Okay, cool. Okay, I got it.
238.
Yeah, I got it. Bro, I'm gonna say it. I think this is a hard one.
Really?
Yeah. Yeah.
Nice. Okay. So let's do it.
Okay, yeah.
It's usually harder to solve on stream as well because when you have the attention, it's kind of embarrassing. You make all
Okay.
these dumb mistakes and you know that
Yeah.
people are gonna watch it. So,
Yeah.
but yeah, I think I'm used to it at this point.
Okay, cool. The thing about it, let's just see the problem, like 1, 2, 3, and 4. So when we get to the position 1, what do we want in there? We want 2 times 3 times 4. 2 times 3, it is 6 times 4. It
24.
is 24. So yeah. In my head, there is a running solution, but I think it is hard to see. But I'll let you try to figure it out.
There is a what solution you said?
In my head, there is already a solution because I did this problem like 10 or 20 times.
Oh, okay.
Yeah. But you can try to figure it out.
So let me see. So I have an integer array of integers nums. Return an array answer such that answer I is equal to the product of all the elements of nums except nums I.
Yeah.
So I need to return another array. answer is equal to the product of all. So this other array has to be just one number, which is the sum of or the product of all the other elements in the other array. Is that correct?
It's kind of, let's just go through the problem. Like, so we have this array called nums, right? So
Yeah.
the first, as you can see in the first example, you have the first item, which is 1, but the answer for that is 24. How do we get to 24? We get 2
Oh,
times
okay.
3 times 4. We take every number and make times the next number, except for the number itself. So we get the first position, which is the 1. So we have all the other numbers like 2, 3, and 4. So we make 2 times 3 times 4, and then you have 24. So the first position, the answer is actually 24. And you go on, like you go to the second position, you have a number 2. So you have to do 1 times 3 times 4, and you get a 12 out of that equation. So you gotta make you gotta go through all the numbers, and you just append to an array, and you can answer that.
I'm trying to think. I think I understand now. I'm just trying to think about. So let me think about the pseudocode solution.
Okay, cool.
So obviously you need to remove first the element, then you multiply. Maybe use a map to multiply all the elements, and then
Okay, that could be a solution. Yeah.
yeah, and then you make the key. You create the other array based on the same index that you use to remove the element of the first one.
Okay, that could be a solution. Yeah.
But I'm
That's really nice.
thinking about how to do that with Python. I'm not really sure.
Okay, that could be a solution. I think that works. But you can go ahead and code it. You can code. You can code as if
Do you think
as you want.
does pop work with the index?
Yes, it does.
Interesting.
Yes, it does. So you are doing the problem in a brute force, which is great, by the way.
Yeah.
Because there is a. If you see the problem, the statement, it says you must write an algorithm that runs in O of n
Oh,
time
okay.
and without using the division operation. So it would be really easy if you just go through all the elements, and then you do everyone times, you get the sum of that. You just make 1 times 2 times 3 times 4, and once you hit the element, you just divide by the number. Let's say 1 times 2 times 3 times 4 is 24. You divide by 1, you get 24. You go again, you have 24 because 1 times 2 times 3 times 4. You get the second element, which is 2. You divide 24 by 2, you get 12. That would be really easy to answer. But the goal here is not to use the division operation and go and do it in O of n linear time. So, but you can go ahead with your brute force solution. I think it is a great start.
I think I want to think about the best one. Thanks for the follow. I don't know what it is, but yeah.
Yeah.
Let me think. So, do you think is the wrong idea to use any iter tools, like iter tools products or combinations or anything like that, or?
You're going through the right, but elaborate a little more about the iter tools, but you're going in the right.
I'm
The
trying
right
to
path.
think about. Let's see. Because usually when I see get all the combinations or like something along these lines, I always think about using the product or the combinations. But it's probably not the best approach, I think.
Yeah. Um,
So what else can I do here?
yeah, you can like you can think about um the solution that I just gave you. Like, how
Like
can you think
multiplying all
about
of
that?
them and then dividing by the number in the index.
Yeah, think about that. That's my first hint.
So let me just try to code this and
Okay, cool.
nums. So I maybe would create a different variable here as sign.
Okay, cool.
But how would I get the? Can I use map to get the multiplication of all of them?
You can go through all the elements and just multiply. I think there's no problem there.
And because then I would have to do 2 loops, right? Once you get the multiplication of all the elements, and the other one to
Yeah,
do the thing.
making two loops. As long as you don't do them in a nested way, like you cannot go make one loop and then another loop inside of the loop. I think
Yeah.
as long as you don't do that, you still have a O of n solution.
Oh, really? I didn't know
Yeah.
about that.
Yeah.
Ah, interesting. So I was thinking about it the wrong way.
Yep.
Ah, because I thought even if you used outside, as long as you used multiple, yeah, it makes sense actually because you're not multiplying, you're just setting up, so it doesn't make any difference. Like it makes difference, but not that much.
Yes, exactly.
Okay, so now I have the. So the only thing I'll have to do is divide each one. Maybe I can use the enumerate. Yeah, but I know this is not the solution, right? So,
It is
but I can't
close.
think about any way to improve this at first, at least. So how can I do this?
Once you code it, you're gonna see this the final solution is really close to it.
Hmm. So I have a new list and um, results. I don't even need the enumerate, I think. So that would be the what you're talking about, or not?
Okay, let me just take a look at your stream and see what you're doing.
It's not nums, it's results. It's s
Exactly.
divided a result divided by s, actually.
Result. Yes, cool, nice. So yeah, exactly. If you just return list result, I think this is the right solution, but it's kind of cheating because the statement says you should do that, but it is close, right?
Yeah, so now let me think about. So I can't use the division. That's the problem here.
Yeah. So just return the least result, and you run the code. You're gonna see it. You're gonna see if it is right or not.
Oh, I also have floating points. So what if I?
Yeah, you should use int function. We just get rid of the float functions. Yes, cool, nice.
Oh, so it works. Probably fails on this one, I assume.
No, it's gonna work. Yeah. So this is the answer, but it's
Oh,
gonna run.
division by 0. So I have to take care of the 0. Okay, but okay, it works. So
Yeah, it works. Yeah, cool. So now you have this problem, right? Let's just think about what you just did, right? You got the result from the first loop, and then you go through all the numbers and divide by the number that you're going through, right?
yeah.
The second loop. Oh, that's cool. But how can we make in such a way that we don't need to divide.
Hmm.
You can submit that solution. Let me just go through the example one more time, right? Okay. Yes, 9 minus 1 it is hard to. Okay, it's not working, but yeah. But let's just take the basic example, and I'll give you another tip, right?
Yeah.
So how much is 1 times 2?
True.
Yeah, cool. Nice, nice. So we have 1 and 2. So how much is 2 times 3?
6.
Oh, cool. Nice. How much is 3 times 4?
12.
Cool. Nice. So the first solution is 24. What if we are in the position 0, right? What if we sum 2 times 3 times 4? We get the solution.
Yeah.
But if you do one loop inside another loop, you get a O of quadratic answer, right?
Yeah.
But let's just say
You can
that
create a
we are.
pointer. You create a pointer to reduce the size of the array and then multiply the
Oh,
rest.
cool. Oh, nice, nice.
That's the
But
solution? Or?
yeah, you're going the right path. Yeah, you're going
Mm.
in the right path, definitely. But how about we can like maybe we can just compute all the leftmost and all the rightmost.
What do you mean? Like, get the
What about
product?
yeah? What about we have an array that just has like what about we have an array that starts like 1 and then 1 times 2 and then 1 times 2 times 3 and then 1 times 2 times 3 times 4. We starting from the left and we are going for the right.
So creating... I think I might be close to understanding. So you're saying that I should compute the multiplication of the neighbors
Oh, cool. You're going in
each
the right
time.
direction. Yeah. But how about I have this pre-computed? Like I can have it, like I just say, let's imagine that we are in the position 2, which is A3, right?
Yeah.
But what if we have like 1 times 2 and we have this is our leftmost, right? 1 times 2 is our leftmost. We can have that pre-computed. And let's just say we have 4 in our rightmost. So if you look to our right, we have 4.
Oh, okay, so using 2 pointers, like I get the multiplication on the left and multiply with the right.
Yeah, but what if we have this pre-computed, so we don't have to multiply every single time?
On a hash? Or
Sort
no?
of, sort of. I'm just put the.
I'm
I'm
trying
just.
to just see. I think maybe I'm getting close, but
Yes, you really close to that. I'm just gonna put this in your Discord. A message. It's just another hint.
easy game, easy life, not right now, man. But maybe later or some other time. What I'm thinking about is creating a hash map and then getting the... Actually, I'm thinking about creating 2 pointers. And... Yeah, but I would need to Yeah, because I can move the 2 pointers and multiply and get the sum each time and append to the other array. So if I
Yeah, but
start from the right to the left, I can just move the pointer and multiply, but then you're saying that it's going to be greater than ON, I think.
yes, exactly.
Yeah, that's the issue.
What I'm saying is that maybe you should pre-compute all the numbers from the right to the left, and then you should pre-compute all the numbers from the left to the right. And then when you hit the index that you are, so you can just sum what is from my left on this pre-computed on this pre-computed list. You can just look, okay, so to my left in my pre-computed list, what do I have? In my right in my pre-computed list, what do I have? So you can sum those two numbers, and then you get the answer. Does it make sense?
Kind of. But then how do you get the pre-computed list? Don't you have to
You
create
can
the
go
2
through.
pointers?
No, you can go through all the elements.
This is the code that you...
I just I sent you a piece of the first part.
Okay.
Like I said, I'm making the cumulative from the left.
So pretty much n is the length. So you're creating a list with the same size of
Yep.
the nums. And then you're making
Then
the first element equals to 1.
Yep,
Running range 1 to n.
exactly.
Uh,
So you can print it out, the cumulative from the left. You can print it, and you're
let
gonna
me
see
erase this other part here. Print
but
this, or...
yeah, yes, just print it. This is that's what I said.
Oh,
It is a hard problem because
but it's good. Yeah, that's how we learn.
yeah.
Okay, so it's
Okay,
giving me
cool.
1, 1, 2, 6.
So imagine like, so okay, cool. 1, 1, 2, and 6. Nice. Now imagine that you can make the same thing, but you can start
From the
from your
right.
right and go to all the way to your left.
Hmm. So if I put the same loop but with -1 steps
Nice, nice.
and create the same thing here,
Yeah, cool.
but I'm not sure if I understand. I think I understand what you're getting to, but not how do you come up with the logic. It's kind of hard to think about it.
Yeah, that's that comes
With time.
with practice. Yeah.
Yeah.
It's kind of a dynamic programming answer. If you ever face yourself with dynamic programming problems, you kind of figure out that you have this tabulation technique, let's say, where you can pre-compute all the numbers. So when you get used to dynamic programming, you're gonna see this. You're gonna see this. Oh, okay. So I can use a pre-computed values. So you're just gonna figure it out. Okay, dynamic programming for that. That's why
Isn't dynamic programming recursion for the most part?
sometimes yes. This what do you say in dynamic programming when you use the recursion?
Yeah.
Maybe you're talking about backtracking, which is another technique. But dynamic programming problems are always like memorization. Yes, backtracking with some improvements, which is memorization with some caching. And then you can come up with tabulation, which is exactly like this one. You can come in grid formats. So you have another set of problems which are considered grid problems. So yeah.
And what makes you think when you look at a problem like this is gonna be a tabulation problem? How do you know that?
Okay.
Like,
So
what's your thought process behind thinking about this solution?
this is a great question. This is a great question. I'll send all the whole solution for this. Maybe that's make it clear. But yeah,
Yeah, sure.
this is a hold on.
Like I said before, I don't really care about solving the problem. I care more about understanding how it should think.
Yeah, so if you go, the first example is it is great one. Like, um, you can see that if you go like if you are in the position number, if you are in the second position, or if you are in the first position, you have one, and the answer is 2 times 3 times 4. So if we are in the first position, you look at your right and you say, okay, so my answer is 2 times 3 times 4, which are the numbers in my right. Is there a way that I can pre-compute all those numbers? Because you're gonna do a O of n in a quadratic way, you can make a loop inside a loop. But to avoid that, you can tabulate all the results prior of that. And so when you are in the first position, you'll say like, okay, the answer are all the numbers to my right. When you are in the second position, you say, okay, so the answer is all the numbers to my right times the number to my left. So if I have a kind of a table, I can pre-compute all the numbers. I can have to my right the first number, which is a 4, and then times 3 as the second element from my rightmost. And if I look to my left, I just have one number, which is 1. So I'll take whatever number is to my right times whatever number is to my left, and that's the answer. But you're just able to see that if you go through the example. Like,
Doesn't it make more sense to do the computation as you move through the list? Like, why do you need to store both of them? I guess because then you're doing each time. I think I get it now. Yeah.
yeah,
So you
because
do only one time and then you just look it up.
yes,
Interesting.
exactly. Tabulation, in your head, just like you said, okay, maybe I go to a hash. I think in your thought process, you were going to a hash because you believe it's O of 1 to access it, right? So
Yeah.
you know it is really fast. You can, okay, just give me this number. It is really fast. What about you pre-compute all the numbers and you have it in a table? Like imagine a array, but every time that you access some position in array and you say, I want this position in this array, so you have O of 1. So you have all the numbers pre-computed. You can access exactly the number that you want.
So would you say that it's fair to think about tabulation as an extension of a two-pointer thinking?
Yeah. Yes.
Ah,
It is the same
interesting.
thing. Yes.
Because you're just saving space because you're gonna have to do multiple times, but if you do only one time, then it's better to do two pointers.
Yeah. Yes, exactly.
Uh,
You can think something like that, but everyone has his own way to figure it out. Just hold on 1 second. I'll take my charger. Just
yeah,
hold on.
sure, of course. I think I'm gonna grab something to drink. Let me just message him. Alright, I'm back. Let me see the solution you post here. I think the thing that I got wrong was the output and the index there, I think.
So I'm back. Yes, so if you print the cumulate from the right and cumulate from the left, it's gonna be pretty clear for you, the answer.
I think I'm gonna erase this stuff here. The thing that I have a lot of trouble with is these indexes as well. And sometimes it's very confusing to think about it. Like, why do you do I-1 here? And then I here?
Because I have to cumulate, I have to have the cumulate, I have to have the cumulate from my left. So I have to look at the number where I am right now, minus the number before me. If you see, I always start with a 1 in the position 0, so that I can look like, imagine that I'm the first position, right?
I think
In
I
this
get
case-
it, but what happens on when I equals 0?
What happens when you...
When I equals 0, isn't it gonna give you the last element of the list? Because it's 0 minus 1, so it becomes minus 1.
Not exactly, because if you see in the line 5, I set the position 0 to the value of 1. So in this example, in the nums, like I'm starting the second, I is equal to 1. So in nums, so I access the position 0 times 1, so which gives me whatever number.
In my mind, it would be something like this. The way that I'm visually seeing in my head, I replace 0, the first iteration. And I replace this with 0, and this with 0. So in this case, here it would be minus 1, and then 0. So in my mind, it would make the first number of the cumulative from left equals to the last number of cumulative from left plus times the last number of nums, which it would be 0. Or actually would be the last number, which would be 4.
Yeah.
So that's correct.
Yeah.
Ah.
It's just a little trick for you to get the result, but yeah, if you debug it, you're gonna eventually crack it, like to say, okay, so now I get it. But I think it is pretty clear when you just print it out, the cumulative from the left and the cumulative from the right. If you just print it out both of them
At the end here,
of the
or
computation, at the end of the computation, but before return out, yes, cool, yeah, cool. Yes, there is a little delay.
yeah, no worries. So from the left is 1, 1, 2, 6.
Okay, cool.
From the right is 24, 12, 4, and 1.
Okay, so let's say you are in the index 2, right? Which is a number 3. So if you look for your left, what you have is 1.
Yeah.
And if you look to your right, what you have is a 6. So you have 1 times 6, and that's your
6.
answer. Oh, by the way, yeah, I was wrong. You get your position times your position from the right, your position from the left, 1 times the other, and that's your answer. In the case that index 2, so you have 2 times 4, because from the left, in the position 2, you have a 2. From the right, in the position 2, you have a 4. So
Okay.
2 times 4, it is a 8.
Oh, yeah. So you're pretty much getting the number at the index, but on the table. And then you're
Yes,
multiplying the left and the right.
exactly, yeah.
But it would be really difficult for me to think about it in this way.
Yeah,
It's very, very interesting.
yeah. Just because for you to get the same result, you have to do a loop inside another loop. But when you are doing a loop inside another loop, what you're actually doing, you're doing like all the numbers to my left, the product of all the numbers to my left, and times the product of all the numbers to my right. That's what you're getting in a loop inside of a loop. What if you just has this pre-computed, right?
Yeah. Really, really interesting.
Yes.
I'm just trying to think about, next time I approach a problem like this, how can I think about it in this way? And to me, that's the hardest question.
Yes, like I said, it is a hard question.
Yeah.
The solution is not clear. Um, for you to get used to tabulation, which is this technique that I just told you, you have to go like you have to make a 1 week tabulation problems.
I, I,
Like
I think I get why you're saying is dynamic programming solution, because you're kind of memorizing the values, right?
exactly, yes.
Ah,
This
interesting.
kind, but this is not kind of memoizing. We use memoizing in recursion problems because we already had them pre-computed, just like Fibonacci. In this case, we call it tabulation, but you can look that on Google. You're gonna see a lot of articles about tabulation because you actually have it's kind of a catch.
Do you
You
know
have
any practical? I know it's hard to. If you don't know, it's completely fine. But any practical things that might use this? I know the
yes.
cache is used on URL lib, I think, but outside of that, I'm not really sure.
So you were talking about Google Maps. Google Maps used a lot of tabulation technique as well.
Mm.
Um, you have this in all sort of let's just say financial problems where you even talk about stock market or stuff like that. So you have a lot of tabulation as well. So this algorithm can be implemented in real world. Like if you just worried about that, that's a problem that come up a lot of times. Trust me, a lot of times. Yeah.
Yeah. I probably won't be able to
Identify
think
them.
about this on my own next time, but I think at least right now my understanding is a lot better than before, for sure.
Yeah. In order to understand tabulation, you kind of have to have a feeling like maybe it would help if I have this pre-computed. Like, how can I pre-computed things in a way that I can use them after that?
And why do you use a list instead of a dictionary or a hash, whatever
Um,
you want to call
you can have a hash, but I think it would be way more complicated, and the result would be the same because in a hash, like you just said before, like when we were talking about heaps, right? You just said, okay, so cool. A data structure, it was created in order um, to make something easier. Like let's just say heap. Heap was made for rankings. So we have this problem about ranking. So what kind of data structure can we have to solve this problem? So they come up with heaps, right?
it. Yeah.
So dictionary, why they come up with dictionaries?
I think
They come up
go on, sorry.
they come up with that just because okay, so we have this key and associated to that key we have all these values. So can we get all these values if I just pass this key? And this kind of is the problem. But in your case, right here, um, a array would have the same effect that a dictionary, because you just want the O of one access, and when you access an array and you already know the position, is O of one as well. So
Yeah, I think I understand because you're trying to preserve the order.
yeah,
So a list is better because dictionary makes it harder to preserve the order of information because you're trying
yes,
to get left and right.
yeah, you could have like a leftmost dictionary, and then you pass the index and it gives you the leftmost. You can have your rightmost dictionary, then you pass the index, you get your rightmost. It would be the same effect. Yeah.
So the only thing
Okay.
before we go to the next one, I'm trying to make sure if I understand the thought process behind the index. To me, that's the trickiest part, I think.
Okay, cool.
I would never come up with I minus 1 here because it doesn't make a lot of sense. Because I think I understand it. Like, you're getting the left. So the left of the first element is the last element, let's say, because you're going like that. But I wouldn't think about it in this way, I think. So
Okay.
what I would do intuitively is make if I bigger than 0 and then make the condition. So,
Okay, that could work as well. I just
oh, it
think
does
this
work.
is. I think I got this answer from LeetCode.
Mm.
So I think if you watch the video, it will be the same the very solution, the same solution. Maybe he has a drawing or something like that. But keep in mind that in the line 7, I'm starting my loop at the position 1. Um, Sometimes I think,
Oh, that's the thing that I'm getting confused.
yeah, I'm not starting
Ah,
from the
yeah,
index
yeah, yeah.
0.
Now I get it. Yeah,
Cool.
interesting. And then
Same
here
thing.
doing the same thing, but from right to
Yeah,
left.
exactly. But you can start at the position 0 as well. It doesn't really matter. You just have a if statement, just like you said. Like you said, if it is 0, I'll do this. If it is not, I'll do that. Would be the
Mm.
same effect, but yeah, a little more code, I guess. But the same thing.
And then you're just looping through the array and getting the left and the right.
Yeah.
Very. Damn. That's crazy.
Yeah.
Let's go to the next one.
Okay.
I probably, just letting you know, I'm probably not gonna remember if the next one is similar to this. I'm pretty sure I'm not gonna remember how to do it exactly, but I understand the principles now. It's gonna take time until I know how
Yeah.
to implement it off the top of my head.
Yes.
How many of
And
these have you solved? You have been
almost
programming
for
for
almost 400 in
god
lead code.
damn, man.
Yes. I'll send you my profile, like if you want to take a look. But
Yeah, sure.
uh, almost 400. But let's just say that LeetCode Blind 75 is a great, great start list. Oh, that's awesome list. If you're, I mean, if you're going like for the purple bank that I'm working, or Google or something like that, you can see my consistency is my biggest problem. I'm only doing lead code when I have some interviews coming up.
Nah,
I'm
you're
trying to
fine,
fix
man.
that.
You're
I'm
crushing
trying,
everything. That's
I'm trying to fix that, but yeah. So the thing in here, consistency. What you're doing is great. Blind 75 is a great list. Just because you're gonna see all these concepts like tabulation, memorization, backtracking, recursing, sorting, all of these problems you're gonna see in the Blind 75 list,
so
which
do you
is
think I
great.
should move to this one and start from here?
It's up to you. It's up to you.
You know,
Uh,
you have more experience, so you know better. I'll
I
do
think,
whatever.
in my opinion, yes, blind 75, you just start with that because there is a lot of concepts in there like slide window and trees and heaps and dynamic programming. So you get used to that. So blind 75, I used to do blind 75, all the 75 problems in 2 hours, I think, 1 hour and a half, something like that.
Each
So I
one,
got,
not the whole list.
yeah, no, just the whole list in 1 hour and a half or 2 hours. Because just because I remember the concepts and I could answer the same problem in different ways. Like for example, I could solve it merge linked lists. I could solve that like in 5 different ways.
Yeah,
I learned one from LeetCode, and after that, I just tried to myself. I try to look at the solution. I try to understand, just like we're doing. So I did to this for all the blind 75 list. After
damn.
that, I was really comfortable to going to like just say Amazon questions, Google questions, and stuff like that. I was really comfortable because I knew that I saw graph concepts like traversal graphs. I know that I saw some binary search concepts. I knew that I saw some heap concepts, and none of that was kind of a surprise for me. And then after that, I just saw the 150. It is a new list. I never did the whole list, I think, but it's something that I'm intending to do. So that's pretty much my plan. I'll
How long did it take you to do the 75?
I think 1 month. 1 month.
But how many hours a day do you remember or
Oh shit, that was 6 hours a day, I think.
god damn.
Yeah, but I already knew the data structures.
Mm. And you think because so far I've been doing 30 minutes each maximum, then if I can solve it, I look at the solution. But do you think this is it's a bad strategy?
It is the best. Your strategy right now is the best strategy. You just put a timer, right? Just like
Yeah.
contains duplicate. You put a timer, and then you go like 30 minutes. You try for yourself. You really try for yourself. And first of all, you can try in a paper, or you can try directly on LeetCode, and just try for yourself. Like when you get to that 30 minutes limit, and then you can look at some hints. Then you can look for LeetCode video. Um, LeetCode video, it is great because he goes for the explanation of the problem first. Then he goes for drawing the solution. And then after he draws the solution, you can try to implement for yourself. And you try like for 10 minutes. So if you cannot implement for yourself, you take a look how he implements for himself. That way you're gonna really learn the concept.
And then you go back to it on a later time to see if you can solve it again, right?
Yes, yes. So I use it this technique called space repetition,
Yeah, yeah. I've heard about that one.
where okay, so I have a list on Notion. I'll send you as well. I have all these blind 75s in cards. So I was making some notes and I was going back and forth like, okay, so I solved this. I'm really comfortable with this. So I put in a different list. I'll show you. I'll send you. You can
Do
copy.
you only code in Python or any other languages?
In my in my job, I use a language called Clojure.
Never heard
I
of
don't.
that.
Yeah, it's pretty much Nubank owns the stuff, but
Uh,
okay. So I use whatever. The thing is, it depends on your. Okay, so I'll send you this list right here. I think I can make it public. Um,
yeah, just let me know if you can show it on stream because
no, it's
if you
not a
can, then
problem.
I don't.
Okay, cool, nice. I'll put a link in your chat, and I send you in your Discord because it is a great tool. The thing about it,
Can I show
what
it
you're
on stream or
yeah, yeah,
okay?
course, not a problem. I think this is public. I just copied from other guy. It is not a problem.
Yeah.
So you're gonna see kind of a Kanban style, right? With all the blind 75 problems. So you can like you have like this is organized in category, but you can organize like for Kanban style. So I get all the problems. I do some notes on that. I have a notebook where I write down some solutions. And then once I get comfortable with that, you can move to Kanban visualization.
Where
Because
is it?
just
Here. Okay, find it.
so this is my space repetition kind of study. So I get all the problems on to do, then I go to repeat, then whatever I feel like I'm really comfortable with that, I just make a stack. There is a really great video on how to study from the I stole this from the guy. I'll send you the video as well, but let me
Normal.
just say that um the thing that you were doing, right? My brother works at Google, by the way, just putting that out because
Nice,
I
nice.
went through this process, my brother went through this process. But you know the company that I'm working at, it is a big company.
Yeah, yeah.
The thing about these companies, this kind of companies, they don't really care what about the language that you are studying.
I imagine
Uh
because it's more about the principles, and
yes,
they wanna see that you know how to think, pretty much. I
perfect,
assume.
perfect. Yeah, yeah. Okay.
But I think my main is like I said before, just someone on stream is I'm not even thinking about from the perspective of trying to get hired. I'm more thinking about from the perspective of becoming the best boss I can possibly be at
Okay.
building anything as fast as I can. So and
Nice.
the difference there is that I'm not studying this with that in mind. It's more like focusing on attraction rather than chasing. You know what I mean?
Okay. Okay. Yep. Yeah.
Yeah.
Yes. Yes. This is like what they say. This is the fundamental things, but from a software builder, let's just say perspective. You heard about Pix was out today, right?
Didn't heard of.
Yeah. Okay. Cool.
I'm
So
kind
we
of
have
disconnected from reality, to be
okay.
honest. Just studying every day. I
Nice.
don't know what's
So
going on.
yeah, yeah. But the thing is, in my whole life, like, let's just say I did software that was focused in like just say 1,000 clients, 10,000 customers using it at the same time, something like that. I work in a lot of companies, but once I got in Nubank is a whole different thing because you're doing software for 60 million people using this at the same time. So scale is a big problem. Is a dramatic problem, right? So I get what you're saying, which is really nice, which is well really done. I think you are in the right path. But
Yeah, thank you.
and then building this kind of software, building everything as fast as you can, um, you may become really good at one tool, right? Like just say React or Swift or something or Java or Python. Yeah, you're really good Python coder, you're really good Java coder or something like that. But to make this kind of big impact to software, which are used for 60 million people, or YouTube or Twitch, which is used for like I don't know 300 million or something like that.
Maybe even
Uh,
YouTube, I think is
it
billions.
yeah, yeah,
Probably.
billions, yeah, yeah, yeah. So you get a whole different thing where everything should be really good. Everything should be like O of N. This all make a huge difference at the end of the day. I was saying this to you because that problem in the Blind 75, which is seeing duplicates, I think it is the problem.
This one?
Byte 75, I think it is contains duplicate. It is the first
Yeah.
fix was out today just because of a similar problem. Can you believe that?
God damn.
Yes, 60
And
million
probably cost
customers.
them a lot of money because of that.
Yeah, exactly. Imagine people are not able to get their money, to get their salary just because a problem similar to this. Imagine that. But of course, you have scale in that. So your nums is not like 10,000 a year. It is the same problem, but the scale is really different. And the algorithm which was implemented was really slow. Like it was O of n times n, O of n quadratic, or n cubic, something like that. It's not a good implementation. Matter of fact, it is not a good implementation in production today. But we identified that and we are able to solve it in a fashion, just like the problem you see in front of you. So I'm saying to you, your path, what you thought about it is really great. Because when it comes to these big companies, I know that you don't want to be hard at, but when it comes to
No,
these
no,
big
no. Not even saying that I don't want to be a part of. It's just that I
okay,
think it's better. It's a better mentality to have because you're thinking about the systems and not you're thinking about the cause and not the effect. That's the
yeah,
difference. It's like
nice,
people study just to pass an interview. That's a wrong way to look at it because they're not thinking about the fundamental principles of the
perfect,
systems you're building. So,
perfect. Yeah, yeah. So we have 60 million customers saying a lot of things on the internet just because a problem similar to this one, and people just did a O of n quadratic, not thinking about fundamentally, just like you said, and yeah, yeah,
but
you're in the right path.
the thing is, that's an extremely difficult problem to me so far. I think this is the hardest problem I have because I don't know if you know a lot about the brain, but usually what happens with human beings is that we have we have the limbic system, and the default of the limbic system is to use as less energy as possible and
Okay,
minimize risk. So
perfect.
our body makes us create ideas that makes us rationalize our comfort zone. So
Yeah,
your natural tendency is always to do what's easiest. And on coding, this is such a hard problem because you always have 5 billion different ways to do things, and it's not always clear which one is the best. And also,
okay,
even if there is one the way that is the best when it comes to code, it might not be the best way that gets things shipped to production fast. So there's always this calculation between how fast you're producing and how efficient and sustainable the code is,
yes,
and your
yes.
choice making when you're designing the structure. So how do you train that? How do you become good at identifying your natural desire to do things in an easier way, and what's the best way to do it? Like,
When
what's
it
the
comes,
algorithm for that?
yeah, when it comes to LeetCode, it is just practice.
Yeah.
Yeah, it is just practice. Like I said, I really grinded blind 75 list. I really grinded that some years ago, like 4 years ago or 3 years ago, something like that. But in general, it comes with experience. Um, like you said, oh, how can I get this code shipped to production and stuff like that? But it comes to experience. But the first thing it is the fundamentals, and the fundamentals you really have to grind that.
And I
That is
think that's
not
the difference, right? Between someone that's really good and someone that's just average or bad.
yeah,
Yeah, I
yeah.
imagine. Makes sense. And do you have any recommendations when looking at these problems of, because my tendency so far is to stop and try to think about the most efficient way. Usually the first thing that I think about and that comes to my mind really fast is the brute force solution. And then I
Okay.
spend a bunch of time, I can say, yeah, I probably can figure out doing it that way, but I know it's
Okay.
not the best. So how can I
Yeah.
think about that?
Nice, nice, nice. That's a great question. Okay, so I know that why you always saying hash map, because like you said, it is what you are comfortable with, because it is kind of what you learned about it. The thing is, the brute force solution is natural for every single developer. It is the first solution. That's why it's called brute force. It is the easier solution. It is the more intuitive solution. Um, there's a lot of people with different thought process, but when I was starting lead coding, elite code is not really natural. Um, I always I always try to code my brute force solution. For you to understand and improve your brute force solution, you have to really know the data structures. And don't get me wrong, there is a bunch of data structures. There is like a lot of data structures, but some of them are really fundamentals. They're really so you should grind. You should really understand all of those data structures. I'll just say like hash, like sets, like linked lists, like arrays, graph.
If you could put on a hierarchical order.
Okay, cool.
Let me create a spreadsheet here. Actually, it's gonna be
Nice.
really useful.
Okay, arrays. It is one. Hash map. It is another one. We'll
Or
say
you're typing there. Okay.
string. String is another one, but string are just like arrays.
What about
Let's say
graphs?
yes, graphs. Graphs. You can have a trees, um, graphs, and then which one? There is this is heaps. It is really important. Heap. This one is tries are more advanced. Let me think about it right now. Actually, I have a really good book that I was reading.
And do you think it's worth it to spend time thinking about the hardware? Because I played a game before called Turing Complete, where they give you the components to build a computer from scratch. But I stopped playing that because I wasn't sure if it's worth to spend the time trying to understand how the components work at the machine level stuff, like the electromagnetic field and the way that things, the gates, the logic gates, how they create memory and cache and all of that. Do you think it's a waste of time, or it might
It is
be
good.
useful?
It is good for you. It's really good, but I think in the stage that you are grinding all those um data structure first, it is a better idea.
Yeah,
That's what I
I
think.
also think so. But eventually down the line, it might be better. It might be a good idea
Yeah,
to continue.
exactly.
Yeah.
Yeah. So this book that I just sent you, it is the best book by far in this kind of problems. I think I just sent you all the data structure.
I'll
Questions are
write it
more.
down on the spreadsheet later. I saw. Thank you a lot for that.
I think yeah. In this book, um you can search for it. A PDF version, you can find it. It's really easy to find this PDF version.
No, I
You
think
can
I'll buy
download that.
it. Yeah.
Yeah, I think in Kindle it's crazy. It is not expensive, but this is a really good start. This is a really good start.
Yeah, I'm just not sure because right now at the point I am, I have some projects, but I'm not sure if it's worth it to create a good impression. So I'm always divided between focus only on lead code and grind this stuff out or build projects as well. Which one do you think
Um,
is best?
it depends on what you want, and then you have to decide for yourself. Like, if you really want to work in some companies, in some large companies, um, like let's just say like big companies in Brazil like CVC, or even Itaú, or even companies of that size, let's just say. Um they will appreciate a lot for your GitHub, for the projects, for everything that you did. Like let's just say you build a app, you build a I don't know, a website. That is great for them. There is really experience. You know how to put websites online. You know a lot about database and stuff like that. If you want that kind of company, go for it. But keep in mind they really have appreciation for tools. Like they really like Java, they really like Oracle and stuff like that, right? But if you want to work in companies like Nubank, like Google, in Amazon, in FANGs, like, you should really grind LeetCode. You should really grind this kind of fundamentals stuff
What about
because
startups?
startups they appreciate a lot of tools because startups want people that are really ready to produce. They want I'll just send a link of a startup that I used to work. Like we have a product.
It makes more sense, right? Because they are not really so concerned with efficiency. They just want to build stuff fast, and
Yeah.
then later on they optimize.
Yes. Yes. Exactly. They want to test. They really want to do a test of their product. So they really want this delivered as fast as possible to the market. This is a startup that I used to work. So
Interesting.
the website was online in 1 week. We didn't have the product. We didn't have the login part. So we just start to sell this kit, and the website was ready after that. So they really want to test the market. So they appreciate a lot of tools. Like this website was built in using Angular. So at the time we were looking for people who are really good at Angular and CSS and stuff like that, right?
Hmm.
I didn't at the time I was hiring. I was the first developer. So I was not hiring people that really know a lot of fundamentals, but they really knew how to build a website. They really knew how to build an API and stuff like that. That's what I was looking for. When you come for FANG companies, like I said, they have a lot of users. So time, best utilization of resource are key for them. So they really want to people who knows the fundamental. They know how a database works, how the network works. They really want people like that because when the problem is to scale, everything that you can optimize will be will have a huge impact. Like like this algorithm that you're saying right now, like this could save like millions of
Yeah,
dollars
it's crazy to
every
think about.
single month. Yeah.
And then imagine the pressure is higher as well
Yes.
because of that.
So in your question depends of what you want. If you want to work for Google, for Facebook, for Amazon, just grind your 75 list. If you want a job in general, just go ahead and learn a tool like React or Java. Java has a huge market, so it's
I think I
really good.
know if it, yeah, because right now I already know React, so that's probably the one that I'm gonna focus on if I build
Okay, cool.
projects. I know
Huge
React, a
market.
little bit of Flask and Django, but not that much about Django. And
Okay,
then I know blockchain stuff as well, but not that
okay,
much as well.
nice. Yeah, React has a huge market, so learning React. But keep in mind that all these technologies that have a huge market, there is a lot of developers, and the salary is not that high.
Yeah,
The companies
my
that
goal is to just make enough money, uh,
okay,
and then
cool.
I'm gonna use that money to build a company or to
Oh, nice.
invest or build trading bots or stuff like that.
Oh, cool, cool. So yeah, because one thing that everybody I just sent you a website. You can open that in your screen, no problem. This
Yeah,
is a
sure.
well-known website, but people tend to look at the salary at these kind of companies in this website. So as you can see, a developer at Google can make more than $1 million per year. So that's why people are really interested at working companies
But that's a
of this.
tricky thing because it's more about the system. money is designed to delegate responsibility. So if you focus on the money, you always lose because you're not thinking about the strategy. At least in my opinion.
Yeah, that's a way of thinking about it. Um,
But obviously, some people that have different values, they have families, stuff like
Yeah.
that. So each one
Yep.
has their own. But for me
Yep.
specifically, it's better
Yep.
to be aggressive and
Okay.
to think
Yeah.
less about the fixed salary, but think more about equity for my personality type and my situation, I think.
Cool. I'm just showing you what's on the menu, what's
Yeah.
on the table. Yeah. But people tend to look a lot to this website um just because of the values. But I know everyone is different.
And you're helping
But
me a lot, man. I really appreciate everything. Like anything you can show me is already really helpful. So
yeah, cool. But I think you're in the right track. Definitely, you are in the right track. But keep in mind that in IT, everything has its pros and cons. You should really know the trade-offs. Like if I'm going for this, what I'm winning from that, what I'm losing from that. If I go for like a heap solution, what is my cons? What is my pros of using this heap solution? If I go for a kind of system architecture that goes for a monolith, then what if I could use a Kafka? What I'm gonna win from that? What I'm gonna lose from that? Everything is a trade-off. Everything in IT is a trade-off. So there is no right answer. Just like I said to you, if you're going for your own company and to learn stuff, yeah, that's great. But what am I losing from that? And what if I just focus in Google and Facebook and companies like that? What am I winning from that? What I'm losing from that? But just that's
it's
what you have
very
to keep in mind.
extremely complex because it involves a bunch of variables, of course.
Yes. Yeah.
But I understand what you're saying. Yeah. I'm not naive about it, about creating a company or anything like that. I understand the risks and yeah, maybe it is better. It depends on the person as well, but I understand why people want
Yes.
to work at these companies. Like, I don't think
Yeah.
it's worse or anything like that. It's just a matter of where you're at in life and your values and things like that. But I
Yes.
think, and I'm not sure about this, but I think singularity is gonna come fast, probably 5 years from now or maybe 10, who knows? But it's gonna come. And I don't know. I just think is I tend not to think about. I think I like to think more about systems and causes instead of getting fixated on these things, like because of where you're gonna work or the interviews and stuff. I think this kind of stuff falls into place once you focus more on the system because everything is connected as well. The companies, the politics, everything.
Yep.
So what matters is this becoming extremely good and efficient at creating harmonic systems that are integrated with everything, the technology. And because everything is going to be automated eventually, what we need to do is find the best approximation of an equilibrium of the distribution of power in social structures so that it doesn't collapse. But I think we have too much momentum right now. So we're pretty much rolling the dice, I think.
Okay.
But it doesn't make any sense to focus on anything that's outside of that. Yeah.
Yeah. That's nice. Yep. Really cool.
So
Yeah.
regardless of the job itself, you probably need to optimize both, right? Yeah. But it's like you're saying, it depending on what I want to do. I'm gonna spend more time on either one because it's a different thing. So I think I understand what you're trying to tell me.
Yes.
It's just difficult to calculate this kind of stuff.
Yeah. Yeah. I'm just because you just asked me which one's better, and I'm saying I don't have the right answer for that, but
Yeah.
you do have. You just have to know what you are, what is the pros for that, what are the cons for that, um, what is good for you, what you're winning from that, what you're losing from that. But the decisions are up to you. But the way that you were going, I can see that you can work at Google, like if you really grind lead code and grind some system designs and get user with that, you can really work in big companies and make a lot of money. But as you said, everyone value a different thing. Maybe you don't value it that much, but you'll be happier doing other things, and it's totally fine. But I'm just saying what is on the table, what is not. So yeah.
I think I'm gonna do as you said and grind this blind 75 here until I finish all of this stuff. Like grind like a maniac, and then after I do that, then I build another project. Do you have any suggestions on projects that you think might be cool to build?
Oh yeah, a lot of that. Yeah,
I was
it's
thinking,
cool. That's
but here's the thing: because the project I was focusing on is something that integrates blockchain with machine learning, but I'm not sure if it's worth it. But it's pretty much the idea is to get data from the blockchain, then integrate that with Kafka and Spark, and then run data analysis and machine learning analysis on that and display on the browser. So I want
okay. Cool.
something that integrates blockchain with machine learning.
Nice.
Can you think about any? Do you have any ideas on that? Or
Actually, no, but I do know a great website that makes machine learning with stocks. But with stocks market, let me just remember that stocks market, Washington. Oh man, I really let me just. I know some sort of. Let me just. I have this on. I re, I remember some sort of project which is similar to what you were saying, but I can't remember the name right now.
sure.
But one thing about it, okay. But one thing about I'm just saying what you just say prior of that. Um, don't get overwhelmed about the internet content.
That's really
Um,
hard to do. Yeah.
yes, because you're gonna see Quiveric one. Yes, I just found this website. Quiveric one. This is a really interesting website. It
Man,
is
just a sec. I need to go to the bathroom. Right back.
okay.
All right, I'm back.
Okay, nice. I was
So
just
this
saying
is-
that. Oh, this website is great.
Go ahead, go ahead.
I was just saying that try to not get overwhelmed about the internet content. But if you decide like I'm gonna grind this 75, you're gonna see a lot of videos saying a lot of stuff on YouTube like, you should have this game plan, you should have this plan or stuff like that. But it's up to you. You don't even need to listen to me, but like if you really want to learn, you can learn your own way. But I just
No,
say
of
that.
course I'm gonna listen to you, man. You have a lot of more experience than I do. I appreciate any insights. And even if it's useless stuff, like who cares? Like anything is a
Yeah.
bonus.
Yeah, but the 75 list is really good, and from that you're gonna grow a lot. And it just from like just say it, if you grind that 3 hours per day, you're just gonna see after 1 week how different you can see LeetCode, how different you can see things in that, and you start to comprehend a lot of you can start of to understand a lot of other problems. You're gonna see a lot of improvements. The 75 is really good.
Mm.
I don't
So-
know if you know Sham Prashad, but Sham Prashad is the guy who did the 75, so you can check his website.
Yeah,
Really good.
never heard. How do you spell that? Can you type it out?
I can answer almost of all of these problems in
Uh,
1 minute.
What I was doing is like the way that I was structuring the things in my mind right now. There's the site called Turing, and I'm not sure you heard about it.
Yes.
So yeah, they have some tests there on data analysis, and that's the reason why I was gonna work on this right now. After I did some of the LeetCode problems, I was gonna work on this so I can train to pass the tests and to increase the
Nice.
chances of getting hired.
Yeah.
But then I also at the same time, because I think it's fun to do these challenges, I really enjoy them. So I was also thinking about, so the way that I was gonna structure in my mind is first finish this project and then focus on LeetCode, but I feel more like doing LeetCode. Do you think
Oh,
is,
nice.
I'm just thinking about just trying to crush all these problems, like do all of them.
Yeah, the problems that you just said, I think there are a lot mathematical problems. They are really focused on mathematical aspect of it. I'm not sure. But yeah. But yeah, it's up to you.
I think I'm gonna do all of them actually.
Okay.
Like spend all all of the minutes of the day doing all of them, and then
I think, yeah, nice. I think I saw you in Euler project.
someone recommended, but
Okay.
I just looked at it in the free code camp stuff, but I never did any problem
Okay, nice.
there. It's because before when I was starting out, I couldn't see the connection between this and. But the more experience that I have and then I get, the more fun it becomes to do these problems because I understand how it works now.
Yeah. Same for me.
It's like you're leveling up, right? In a video game, and
Yes.
it's really fun.
Yes. I watch a lot of people do the code just because I think it is really fun.
Yeah.
Yes. Yes. Okay. Oh, if lane. Okay, nice. If lane is different than your contains duplicate. I think your code is not quite right.
Sure.
Okay. Oh, it is right.
I don't
Yes.
remember. I did this a long time ago. Probably was already solved when I opened.
Yeah, it's just comparing because a set does not have duplicate items. So if the length of a set is less than the length of the array, it means that you do have duplicate items. So yes, because a hash set doesn't have duplicate.
Do you think
So
this is a good solution or there's a better one?
this is a good solution. This is not the most intuitive, but yeah,
Sure. Let's go to the next one then.
you can solve it. But what I'm saying, you can solve it in a more like I just said for you, you have a lot of ways to solve the same problem, and some of them are better than the others. But the one that I would do this, I think it is more intuitive. Once you get used to hash maps, instead of using a set, you can just declare a dict, which is a hash map. And you then you can go through all the numbers in the array list. And if the number, yes, cool. So now you just make a for of num in nums.
Like this?
Yeah, right. And you can say if n in
Not in.
rest, if n
Sorry.
in rest, you just return true. Not in, but you can use the in. You just return true. Yeah, cool. Else, you just make else and then the two points. I don't know.
It's a
And
little
you
bit
can
delay, but yeah, I'm listening.
you can say like res and then open the brackets and put the n, and then you can make it whatever, like equals to true or something like that.
Like the brackets, you say this?
You can say like res and then open brackets and then
Oh,
put n
ras
inside.
and equals to true.
Let me just, like, you can say make just like I sent you in Discord. Yes, perfect.
Yeah, yeah.
And then yeah, because it doesn't really matter what the value of that, but that will be a solution as well.
Just inserting. So this, do you think this is better than the SAT one, or?
I think it's more intuitive,
I think the
but the oth-
SAT, as far as I know now, I didn't know this before today, I think, but the SAT is like transforming a list into a hash, right? Or
yes,
yeah.
it is almost like a hash map. The difference, in the difference is just because a hash map you have a key and a value. In the set, you don't have the value, but you access the same way you access a hash map. So I think this is more intuitive. But as I said to you, on the blind 75 list, I know like I can answer all the problems like in 5 different ways. I'm just showing you a different way because both of these answers you can learn something. You can learn about a hash set, what you just did prior, and you can learn about a hash map, what you just did right now. So the same question, two different learnings from that. So that's the way to go.
Do you find yourself using a lot of methods? I remember you told me that it's not very good because then you can translate to other languages. But I'm just curious, like, do you use either tools often to solve this, or not that much?
Um, the thing about it, I went to a lot of interviews about this, right? And I I interviewed a lot of people. Once I when I got to your stream, I thought that you had a lot of experience, so you can use like the Python tools and you can make it. But keep in mind that if you're going to an interview or if you want to learn, you have to know what those tools are doing behind the curtains. Like I just can put like collections.counter, and then I can just go through the items and say, okay, so the counter of this is 2, so I know there is duplicates. But if an interview just ask me, but what does the counter function do? If I don't know what the function is doing, then I'm gonna fail the interview. And if I don't know what the counter function is doing in real life, I'm not sure if my program has the best performance. So that's the thing. Like
Yeah, my thinking behind doing that is so I force myself to become more familiar with the methods, and so I
yes,
understand how they work, like you said. But I'm not sure if it's the best strategy because I don't see people using it often. Sometimes I've seen on Code Wars, but it doesn't show up a lot. So
oh Yes. Cold Wars is the perfect simple. Yes. Cold Wars, just because they really like to do this fancy answers where they just put one line and
Yeah,
but yeah, yes.
it's kind of like showing off, right?
Yes. That is really cool, but once you know what is really doing, what's the function is really doing, just like the codes that I just sent you, it is another way to answer this. It is a third way where you can answer this, and you can have some learnings from that.
Mm. When you say you know all these ways, did you learn them as you went? Like, did you learn them on the first time you were doing, or each time you did it, you tried to do it in a different way?
Yeah. So, before I try LeetCode, okay, so this return false goes inside the if statement, or it's return true actually, return true inside the
And
if statement.
then return false outside here, or no?
Yes.
Yeah.
This is another way of answer this. Before I do elite code, I went to college, and in college we learn a lot about data structures. So I kind of knew it, but um, in my college it was really cool to have a Code Wars profile and to be the number one of the college. So we kind of have a competition in there. So we learn a lot about data structures and some algorithms. But my goal in here in this blind 75, like I just took like 4 years ago or something like that, was really to grind all the questions. Was really to get the insight and different approaches that I could have in a different question. So yeah, I just gave you like 3 ways of solving this question, and in all the 3 ways you can learn something about them. So like I said, I grinded like for 1 month, but keep in mind that I already knew the data structures.
Interesting. So I think I'm gonna go to the next one.
Yes.
Maybe look at the counter again because I don't remember really well
The
what it
counter
does.
just give you a hash map based on the array, how many times it appears. If you just print
Mm.
out the counter, you're gonna figure it out.
So the key is the value on the nums and the
Yeah,
okay, got
and
it.
the value is the how many times it appeared in the array.
That's why you're doing if it's true, return true.
Yes,
Okay,
actually you don't need to do equal to true. You can say like is bigger than one, is
yeah,
greater than one.
got it. Yeah, so I think let's go to the next one.
Okay, cool.
You can stay how long you want, by the way. Like, feel free. I think I'm gonna go for a long time, so it's up to you.
Okay, just one more, then I go to sleep.
Yeah, sure.
So yeah, anagram. Okay, valid anagram.
Oh, I think I already solved this one. Given two strings S and T, return true if these and oh yeah, this one it was part of the other list as well.
Nice, but you kind of cheated in there.
Yeah.
You kind of cheated. So let's just go back in that problem in anagram and figure out how we can solve it, not sorting.
The way that
So
I did before was using zip, but I also sorted. It's the same thing pretty much.
yeah. Um, is there another way where you can see you can solve it?
I think one way would be to see if the letter of one string is on the other string. So you loop through one string and then you do dot find.
Cool, really cool. Yeah. Do
Yeah.
you remember anything that you can use it to make that faster?
The tabular stuff, but I'm not sure if it's useful here.
Okay, cool. You can use the counter.
Oh, counter.
Yes,
Mm.
you can make like counter S and counter T.
So create a variable,
Yes.
counter s equals is no. What is the library? The calls counter
Collections.
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 with
Yeah.
capital C.
Collections.counter. Collections.counter. I'll just send you a code, but it is almost the same thing that this.
Yeah,
You can
sure.
just say like is equal to this, and then you can say like for a mass.
So we're gonna create two counters and then compare the keys
Yes,
or the values actually.
both of them.
Yeah, both. Yeah, because you need to have the keys and the quantity.
Oh
Makes
yes,
sense.
yes. You got the answer. Yes, perfect.
Yeah.
Really nice. If you have like you can go. First of all, if the size of them is different, you can just return a false, right?
So if
The first
can use
instruction,
length or
yeah. The first instruction should be if the length before counter, because you can improve a lot of your.
oh, okay. Yeah, that's true.
You don't need to count them. You don't need to
Length.
count them if the length of them are different. You already know that it is not a anagram.
Yeah, that's true. Return false. And
You
then
just return false. Cool. Yeah. So now what you can do, okay, so now you know the length of them are equal. So you can just make a for, just like I was just saying, you for key and value in counter s dot items.
so the key is gonna be the key of the counter S or no? Because I'm looking through the values, right?
Yeah, just print it out. Just print it. You're gonna figure it out. Yep. Just say print key and value. Okay,
I
cool.
made some mistake. Oh, I need to import maybe
No,
or save.
collections is AC
Okay.
is lowercase. Collections should be all lowercase. In a real Python code, you should import, but in LeetCode you don't need to import.
Okay.
So okay, what gives you a dot items in a hash key? It gives you the key and the value. Like you can say like dot keys dot vals. Dot keys will give you just the keys. Dot vals will give you just the vals.
And can I
But if
use
you
the square bracket notation to compare? Like to this?
yes, yeah, and then you just put the key, and then you say that if this is different than value, if this is different than value, then you can just return false.
But don't I have to compare both things? So shouldn't put and here or?
No, you're doing the both things because you're getting a value from counter S
Yeah,
and
yeah.
you're comparing this from counter T.
Because if key doesn't exist, they're already gonna throw and they're already gonna skip.
Yes, one way to prevent that, in every hash map you have the get function. So you can have something like counter T dot get, and then here you pass the key, and then here you can pass the default value. Yes, cool, nice.
And then
And then you can
would be
say
like
just
this.
0. Yeah, yes, which is gonna, okay, so you can pass 0 as the full value. If you do value, it's not gonna work.
Or just key here.
Yes, cool. What you're doing is like you're trying to say, yeah, cool, nice. The other way, you are sure that the key exists in this map, right? If you use get, you're not sure if the key exists in the map. So if it not find the key, we just return none for you. So you know that none is different than value, so you can return false.
But am I testing the value with that as well? So I think you're saying if not counter dot key, return false, like that.
You could do that as well. You could do that as well.
And then
But
it
you
doesn't
have
matter the value.
Yeah, in this case, it doesn't matter the value, but the value matters for you because if you want, if you, in the word S you have two A's, you have to make sure that in the word T you have two A's.
Yeah, that's
Perfect.
what I was thinking. So I have to check for both, right? So this one's
Yeah, you
probably
have.
better.
Yes, yes, yes,
And then I just return true as default.
yes.
Let's see if it passes. Very interesting. Yeah, cool. And it
So
seems like
you
it's
have,
the optimal one as well.
yeah. So you can sort the items, and then you can use this data structure called hash map. And then, hash map, there's a lot of methods. So you kind of have to learn all the methods in hash map. But one thing about it, if it was an interview, the interviewer would ask you about what is collections.counter is doing. Can you explain to me what is actually doing and how is implemented?
No, that's the thing. I'm not sure exactly how it's doing, but I understand what it does. It
No.
just gets each value and then counts how many times the value exists. But I'm not sure if it's looping over the string to achieve that.
Oh,
So
that's
I don't know the time complexity there.
yeah. I was asking to you, what is the time complexity of this function? And if you don't know, if you say I don't know, actually means that you're just using, but you don't really know the fundamentals. But I'll just put a code in here, and then you kind of gonna figure it out for yourself. Like,
So I should look it up each time that I use something like this. I should look it up in the
yes,
documentation and try to
yes,
figure out.
exactly, exactly. Okay, that's okay, cool. So, I just send you in Discord, but this is exactly what is this function is
I'm
doing.
gonna copy here just to see or to show. So he's looping through S, then quitting. So it's pretty much, yeah, I know this algorithm already.
Yes.
We used a
So
bunch of times.
yes, collection counter does the same thing. It's just collections of counter is just a Python built-in, which is easier. You write less code, but keep in mind that you have to know what it's doing.
So this is ON, right?
Perfect.
Okay,
Yes.
yeah,
And collections.counter is O of N as well.
nice. Yeah, cool.
So you can see two questions and you can learn a lot from them. Like
Yeah,
you can learn hash sets, you can learn hash maps, you can learn sort algorithms, and that's what I did basically for the Grant 75. And then I went for the notion that I had, and I just write it down. Like I can solve it this way, I can solve this way. If I solve it I sorting will get O of n log n in a quick sort, but if I just do this way, I can make it O of n, which is um, maybe it is better, right? I'm not sure
I
right
don't
now.
remember really well login. I have
Yeah,
to check.
I think O of n is better than yes, O of n is better than O of n log n. So this solution is better than sorting. So that's pretty much what I was writing. Like I was writing, yes, so this problem I can solve it with a hash set. I can solve it with a hash map. I can solve it with a sorting. these are the pros and cons of sorting. These are the pros and cons of hash map. Keep in mind that hash map is a extra space in memory. A sorting is not an extra space in memory. So, like I
It's
said,
exactly like you said before. Everything has ups and downs. So
yes,
usually, the more memory, vice versa. You get what I'm saying.
yes, everything is a trade-off. So, yeah, you just have to be aware of that. So, in these two questions, you pretty much learn a lot about code. That's cool,
I
right?
think I'm gonna do what I was talking about, like half an hour for each, and I'm gonna do all these problems here.
Cool, cool, nice,
And then after that, I do the projects.
cool,
So it shouldn't be.
nice. But yeah, man, I'm gonna sleep right now.
Yeah, sure. It's already
But
late.
that was really fun, man.
I
That was
think
really
I'm
fun.
gonna stop the stream here as well, and then probably solve some off stream, and then probably restart the stream and keep going. But yeah,
Okay,
it
cool.
was really helpful, man. Thank you a
Okay,
lot.
nice to meet you, man.
Yeah, nice to meet you.
Good
Have a good
night.
night. See you. So that was really good. I think I'm gonna do like I said because I'm here for a long time already. So I'm probably gonna, and it's already late here. So I'm probably gonna solve a couple of these, or maybe I don't think I'm gonna sleep today. Probably. So, but I'm gonna solve as many as this as I possibly can, and probably when it's morning here, where people are starting to wake up, I'm gonna come back to the stream and continue to solve them on stream. So yeah, and thanks, Scrooge. Appreciate that. So I'll probably see you in a couple of hours. And yeah. So yeah, see you.